Hey, what's up guys? Hope that you guys, all of you, enjoyed the phase 1, that is first part, which involves the modeling of that interesting contemporary form with all its details, and assume that all of you guys are done with the modeling part of the same. And if you guys, any of you, are facing the problem regarding the modeling of that particular form or that structure, then kindly let me know your doubts and queries in the comment section, and I'll reach out to each one of you personally solving your doubts and queries. And if there are new viewers to this particular video, and if there are new students who are not aware of this particular exercise, then kindly let me inform you that this particular video is phase 2. So kindly switch back to phase 1, that is the first part of the video, because this particular video is going to be the second part, that is the designing of the residential apartment, which will reflect the traditional architecture with Roman styles of openings, that is door and windows and wooden columns. Also, it will reflect the same details of that typical floor details which are there in the previous video also. And also this video will incorporate designing of different types, different wall types with different thickness and different layers, that is acoustics, cavity, insulation, etc., just like previous video. Okay, so it is going to be very interesting tutorial. Watch the entire tutorial till the end. And welcome back to ptscadexpert and myself, architect Kumar Kapadia from the city of Surat in Gujarat. And without wasting a single second, let's jump into the interface of Revit.
So the first step that follows on this particular floor plan is that the exposed columns that you see, a couple of them are going to get wrapped within the wall. For example, this 4 columns will get wrapped within the wall. This 4 columns will get wrapped within the wall, but some of them are going to stay exposed. Okay. Also, these 2 columns are going to get embedded in the wall. So for the exposed columns, just like we provided the finishing layer for this columns, we also need to provide the finishing layer for those columns. Okay, and here I guess I forgot to add 2 columns onto that particular point. Yeah, so where is the AutoCAD plan? And I guess it is at first floor. Yeah, and just take that AutoCAD plan and make it go to the basement slab, and just open the floor plan of the basement slab and just cross check. Yeah, so see, I forgot this 2 columns, but that won't be an issue. What you can do is that just select this column CO and copy from this point, internal point, to this point. Yes, okay, and copy that as well and place it here and rotate it RO, and then move it from this point to this point. And it is already resting on the raft, so there is no point giving it a finishing floor material, and it is of the less size, but that's okay for now. You can just adjust the size. What my point was that to lay that particular 2 columns. Yeah, so see, now they are part of. Okay, And what we need to do is that let's see in the AutoCAD plan that those two columns are also going to be part of the wall, so they don't need to be applied the finishing material at this level. Yeah, see, they are part of the wall, so no point applying material. The finishing layer of material will be applied to this 1, 2 and all these columns and these two circular columns. So let's just do the needful. So this will be again an interesting process. I will just press HR and what I'll do is that I will select the portion wherein we are going to apply that finishing layer of material. Okay, and press control and just deselect this and this and also this beams. Actually we can filter it, though not an issue. And herein this two, 1 and 2, okay, and this one also, and this anyways is going into the ground, so there might not be a finishing layer, but this column does have finishing layers. Okay, so now just filter, and from that just check none and check only columns. That will select only the architectural columns, apply and okay, fine. And with that selected, just copy to clipboard and paste, align to selected levels, and then just copy them to plinth ground floor. And you see how beautifully the columns, the architectural columns, the plaster, the layer of plaster only which we wrapped to the structural columns has been elevated. Only thing is that you just need to change the constraint and top offset to 0. How easily we can work with Revit, and all the rest other columns don't need, because they will be get embedded in the wall. And this column I guess was supposed to be copied, rectangular column, yeah, fine, copy to clipboard and align to selected levels and take it to print ground floor. Okay, and just change this constraint to first floor with the top offset of 0. Okay, now for this two columns and these two round columns we are going to apply this same material. Okay, so what I'm going to do is that select both of this and edit type, and for the round column we don't have that, so just duplicate and again be specific, expose round column. Okay, and from plaster just change that to that particular finishing material, expose column finishing material, apply and okay, fine. And rest all this other columns, 1 and 2, 3, 4, which are going to stay exposed. I need to, and this are the columns of the same size, so this is going to get embedded in wall, so no need of providing a finishing layer. And this multiple categories selected. Okay, so let's just select this one and SA, that will select all columns of that particular type. But again we need to deselect the lower part, so shift and just the cross window, so that will deselect, again shift and deselect this. And for all this, these are the same types, let's just try, so that won't be the size, or actually duplicate, edit type, and all this 2 feet 3 inches, or just 2 feet for now. Okay, and change this to 2 feet 1 inches, rename as 2 feet 1 inch, OK, apply and OK. Perfect. Guessing games are sometimes helpful, and you see by mistake I added this, but that's not a problem. 2 feet by 10 inches that already exist, so not an issue. And I need to get rid of this. Fine. Only thing is that I need to lay this 2, so that we have to go to the designated floor plan, which is the plinth level ground floor, and onto that what we have to do is columns and column architectural and round column, and under that we have this 24.5 expose column, expose round column. See how specific, and duplicate. So this is how we can find if we have given the name perfectly from it, and that would be 18.5 expose round column, and just change this to 18.5 and apply and OK. And before placing it, just right, just that, so that will exactly snap. And likewise here, just turn off the line weight, go to 3D. See. So regarding the joint conditions, I hope that you know that if I go to each and every junction, then that would take a lot of time and we won't be able to complete the tutorial. So regarding the joint condition, only thing which we can see and which we can witness on screen, we will deal with that and we will rectify that. Otherwise, for the rest, you can just spend the time and do the needful. So HR, and yes, these columns are being exposed, so modify and join and select the structural column with the architecture, and likewise structure with architecture, and why is it not joining properly? Okay, did join, but visual appearance was a problem. And all this column, structure with architecture, and join, select structure with architecture, tab structure with architecture, structure with architecture, and tab structure with architecture. Okay, and the same for all this. Tab until you find the structure, and then structure with architecture, structure with architecture, and last structure with architecture. And see, only thing that these are the columns with different size, bigger size, so again we need to give them 1 cross 1, so 2 feet 7 inches, and edit type and duplicate and call it 1 feet 1 inch expose column. OK, and 1 feet 1 feet here, apply and OK, and no issues. And you don't even need to join it because you have already joined that. Okay, fine. Now we can continue with the modeling part of this. Why is this creating a problem? CC R enter. Okay. Sometimes changing the visual graphics do the needful. Okay, so from this point now we are going to first add the staircase that will take up to this particular portion, but before that let's add this wall. Why is this wall not yet joined? HH HH and join tab. Yeah, but here there is no beam, right? Fine. The beam grid is here, so that's why. Okay, no issues. HR and go to this plinth ground floor level, and first let's construct this wall, for which we need the floor plate. So the AutoCAD plan footprints, not the floor plate, footprints, and just again take this back to plinth ground floor, and this is the only structure which you can visualize. And again VG. This is really annoying that every time we have to change the graphics. Okay, and with that, now what we are going to do is architecture and wall and main wall, and this I'm going to edit type and duplicate and call it stone wall. Since we are going to apply a stone material to that, we need to duplicate this and edit, and everything remains the same. Only thing is that we need to change this to the stone wall. Yeah, here it is. Here is the material. We have already defined it, so we don't need to waste time on that. Okay, and that same here. Okay, apply and okay, and now just pick lines wherein I'm going to say that the core face interior 1 and 2 and 3, and this I think we should draw. So walls and stone wall with not unconnected, but let's take it to the first floor. Wall and wall. Yeah, and just, is it drawing proper? Press tab. No, it should actually snap. We are supposed to snap to this point, or actually let's just pick lines and create one. Yeah, okay, and just this TR join with them. Okay, so let's take this all the way to this point and let's see it in 3D. Wow, and this should also go up to the first floor, and same till the first floor. MA match properties are here. Okay, so this will be that highlighted stone wall highlighter, which will have the cladding which would appear like a stone. If you want, you can actually design a stone wall, but that should have again the step footing, so I'm not going into the detail of that. I'm just playing with the material part. Okay, and now we need to lay the staircase, which will take from this particular plinth floor up to the first floor plan, and that will be the interesting part. So Revit doesn't provide such staircase, neither that you can create such staircase by sketch. So what will be the trick here is that this much portion of the steps we will be constructing by this component model in place, and we will give it a genre, that is the category of stairs, so we can schedule that, and that this particular staircase will be the regular staircase. Okay, so model in place and stairs, and okay, and stairs I would say plinth level, plinth to first, let's be specific, and extrusion, and I will just pick lines 1, 2, Actually, let's have a complete close shape with lines, and this would be 0 to 6. Lines cannot intersect each other. Where are they? They are not. Yeah. And then the WF, that is wireframe, create extrusion, pick lines, and 1, 2, 3, and 4, and that would be 0 to 12. I'm considering 6-inch thickness of one riser. Then again create extrusion, and 1, 2, 3, and 4, TR, and 0 to 18, and then create 2 more, 1, 2, and 3, and 2 feet, 2 feet. Okay, and then create extrusion, the last one, 1, 2, and 3, and that would be 2 feet 6 inches. Okay, so from this point we have already covered the height of 2 feet 6 inches, and now from 2 feet 6 inches it should go up till this particular 13 feet. So 10 feet we have to cover, and there should be 20 risers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I guess somewhere I am going wrong. Okay, this particular plinth, sorry. This particular plinth is on 3 foot. See, there is a 3 foot of plinth. Yeah, fine. So from there we have to calculate 20 risers. So these are 15, 16, 17, 18, 19, 20. Yeah, okay. So halfway we have reached. Now we have to reach from this to this level. Yeah, so doesn't matter. And I will just finish this, and I would say that architecture and stair, and I'm just going to select this monolithic stair for now, and from plinth level but with the base offset of 2 feet 6 inches and with 15 desired number of risers, 15. Okay, see, so actual riser height, it automatically calculates that 15. Fine, perfect. And run, and from this point to this point, what is the tread depth? Sorry, 1 feet is the tread depth. So actual tread depth 1 feet. Yeah, fine, not an issue. Yeah, fine. Run, and from this point to this point, and convert into sketch base and edit sketch. Okay, and just select this couple off and move it to this point. Move this line here and move this boundary line over here, and TR, and join this geometries, and with this trim X and multiple elements, select one, trim, and trim this line, and 1, 2, 3. Okay, and likewise 1, 2, 3, and okay. Next we have to let's add the risers manually, and from copy, and since we have converted it to sketch base, so we can add that manually, and move and this point to this point, and copy here to This is the parapet line. Yeah, this is the stair riser. And with this, only one remaining it says, and we have a closed shape, 0 remaining. See, 15 risers created and 0 remaining. And just join this to this, and just finish. Invalid stair path. Okay, yeah, this is the stair path and should pass through all the risers, and just finish. Invalid stair path should contain both riser and end. Yeah, continue and finish. Oh yeah, okay. And with that, finish. It's taking some bit of time to regenerate, and cancel. Okay, and let's just watch our staircase in 3D, and that has been beautifully created. Wow, going up to this particular level. Just remove the railing from this side and change this railing to glass panel bottom fill. Okay, CC, and yeah, let's just see it in section whether it reaches up to the designated level, and we already have that section, so just click and this level should be 6 inches. So 6 inch will be the slab thickness that will act as a riser, and onto that we will have the finished flooring layers. So beautiful. Okay, only thing is that we need to apply it material, but right now I want to concentrate on the modeling part because we have spent a lot of time dealing with materials and joint conditions and all that, and because of that we are not able to concentrate on modeling. And I will just brick beds, can't say brick beds here, oh, sorry, and stone, black stone, and okay, and finish. And this let it be a concrete, so R enter, and yeah, okay. Existing material of Revit for proper visual appearance. Why? Okay. And balusters. Okay. Apply and okay. Apply and okay. And top rail. Top rail elements. Railing and the top rail element, elliptical, and the material same, apply, okay, apply and okay. Fine, let's look better. Only thing is that balusters, okay, if we are doing then just let's do for that also, but that we will have to change not from here because the baluster materials cannot be, that is the hosted family, so we need to change that family from the material from there. And baluster square 3/4 of an inch and baluster steel upright, so we will find that under stairs, no, so not stairs, that will be, this will be under railing, and yeah, baluster square and 3/4 of an inch, type properties, apply that material. And for steel upright, baluster steel upright, where is it? Yeah, here is it, and that too, type properties and change the material. and yeah, so that looks better now. You can apply any custom material, but right now just going with the fine. Next, I want to take all this walls, that is the lift shaft and this particular stair cabin, and also there are a couple of walls on this particular designated level which I need to elevate. So let's just first select one wall, press tab, so it will select the chain of walls. Then select this one wall and press tab and select that. Okay, sorry. Select one wall, press tab, and then select control and select that wall, and then press tab. That will select all that walls also. Okay, and then just change them constraint to first floor. Okay, so with that all this walls will be elevated to the first floor, and then let me just go to 10th floor, and here we need to construct some walls, but we can do that here itself, and then we will just copy that walls onto that particular portion. So architecture, walls, and a regular wall, main wall, where is it? Main wall 9-inch, yeah, fine. And with core face interior selected, exterior, just flip the direction from here to it's not create one. We can also pick the lines, but I just want to draw it for now. Here to here, and from here to here. Okay, and press space, flip the direction, join this, and select this wall and press space, and TR, join this with this, and likewise join this with this. Okay, one last. So select this, CS, and pick lines and place that wall. Okay, likewise we already have this stone wall onto which we are going to provide a door for the access, but we need a door over here, and there are two windows, and also this will have. So let's just split this wall and provide a cut, a random cut. Okay, just select this and snap it. Okay, and the height, the top offset is 2 feet, base constraint minus 2 feet. Let's see it in 3D. But we cannot visualize that. Why is that? We cannot visualize. Where was it all created? Okay, they are created in here. Yeah, fine, that's okay. And then according to your design, you can just adjust this height, the cut that we provided in the wall, and make it appear like a puncher. Okay, which will be a see-through for that particular flower bed. And likewise here too we need that same puncher. So copy and copy it from constraint unchecked and copy it from here to here. Okay, so in this both the walls we will have the puncher, and for this particular wall we need to provide doors and windows. So door and load family, that will browse to its location, and from that select this door, residential, and double door, exterior double door. Yeah, fine, that's okay. Yeah, this first one is better. Open, and from that just select this size. Selecting the size is not important. You can adjust it according to your preferred size, but important is to place it. Okay, and then what is the width of this? And modify and snap from here to here. Yeah, exactly, to 6 feet. So why did it snap? And yeah, okay. And then two windows onto here, and one a little sliver, small sliver over here. What is 1 foot? And what is the dimension of this? 2 feet. Okay, so architecture, window, and fixed window of 2 feet by 2 feet. That's okay. Place one here and one on, or let's first place this and then we will, okay. And if you just plinth level, the offset from work plane, that should be 3 foot. Oh sorry, window, and yeah, sill height of 3 foot, that's fine. And the height is 2 feet, we will give it a height of 4 feet. Apply and okay, and then copy it from this point to this point. And likewise, just a small sliver, which we can actually provide a piece of glass, we don't need to provide window. And onto that we'll just place this curtain wall from plinth, ground floor, having 15 inch of sill height, and up to, let's give it an unconnected height only of, let's say, 8 foot. That will be our lintel. And just snap from here to here. Highlighted walls overlap one of them. Is it not automatically embed? Yeah, so you need to check this automatically embed in order to occupy that space. Okay, and with that we also have a cutout over here, so we could have extended this here and place that same CO. Yeah, but we cannot. So architecture and wall, and place that. Okay, and just snap to this point and this to this point. Okay, yeah, and the same copy CO from this point to this point, but just make sure that you snap to, let's have it at least 4 inch. That's enough. Let it extend from here. Okay, and just let's go to 3D, and you see windows and door and everything is placed fine. But what is the height of this door? Height is 8 foot and sill is 0. And why is this not snapping the lintel? 3 foot of height, yeah, and 5 feet of height. 3 foot of sill and 5 feet, so that the lintel is matched. Okay, and this will have a full cut, but this will have a little bit of, okay, you can adjust it manually. You can also select this dimension, no. Okay, after doing so much, just select all of this and go to plinth level, and from this point move it to, let's have some authentic reference. Yeah, move from this point to this point. Yeah, and that will be placed. Okay, so only problem is this cut, which we need to adjust a bit. Let's do it in 3D. ZA. Okay. Just drag this a bit. Oh, not allowing to. Just delete it. This one is perfect. Okay, and let's manually again create a cut over here. So wall and place and place. Okay, and just go to 3D. Just, yeah, the bottom stays the same. You can adjust the height according to the sill height. So right now saying 2 feet 1 inch, let's keep it 2 feet. Yeah. Okay, and this you can adjust it as per your need. Fine. Somehow this walls, okay, chain of walls, press control and again chain of walls and control and select this, and the top offset varies the top constraint, so that should go. Let's first floor, and then this might not be going till first floor. Why is this level difference? Tab and select the chain of walls and select this wall as well, and top offset is grayed out, so we have to do it manually. Top offset 0 and then MA, select all the walls and just reduce it. Fine. Okay, so this 2 needs to have 0. MA, yeah, MA, okay. So now with this we need to join the structure part, and also now, but let's first join the structure part. So join and select this tab structural column and select the wall. Yeah, fine. Select the structural column and the wall, select the structural column and the wall, and structural column and the wall, and yeah, and this was remaining. Yeah, fine. Okay, so this was not supposed to be taken. So yeah, unconnected height and unconnected height of 3 foot. How much is this? 3 foot 9 inches. So 1 and 2, 3 foot 9 inch. Okay, perfect. Next is this particular office area, and this particular plinth floor plan doesn't have much of built spaces, only this office area is there. So again, let's go to plinth, and this particular floor plan is referencing, so I don't want to take the pain of swapping between AutoCAD plans. If we ever happen to snap it to wrong line, then might end up in error. So let's just produce model that here, and just like we did here, we'll model it here and then swap to that particular, because the next step is to model this particular floor, so let that AutoCAD plan be there. Okay, so WA wall and main wall, and just pick lines, and very important that what are the constraints: plinth ground floor, base offset 0, and first floor and top offset 0. Okay, and then just pick lines. Oh, that I've drawn the entire wall. Oh my god, doesn't matter. And here we have the internal walls, so WA, and we already have that wall defined. Internal wall and pick lines, pick this. Okay, and TR and TR and TR, sorry, not TR here, and just snap this and flip the direction. Okay, and let's quickly lay the openings. And so first is the door, and simple door, single flush. So the height, the 2 feet 6 inches by 7 feet is 84, and the lintel is 8 foot. So right now just let's place it, and this is the door here, and here too we have a wall. CS, pick lines, just flip it, snap to this face and CS and just load that, and then you can manually align to here also we have one wall, so CS and it lines, press space, okay, and then you can just align it like this face with this and this with this. Okay, and here we have a window and here we have a bigger door, so CS, but this time I'm going to select this 3684 and just place it. Okay, and this both should be changed to 3084. Okay, and here we have a full window, so architecture and two windows. What is the width of this window? Modify and align and tab 8 foot. So we need to define two windows. One is window and that particular sliding 12 foot. We can actually lay that 12 foot window here, but that has the sill height of 3 feet, so edit type, and that has the height of 8 feet. That is too huge, so duplicate and 12 foot length office, because we need to change the constraint, so that's why we need to duplicate. And I want the height to be 6 foot 6 inches, because 18 inches is going to be the sill height for that window. Apply and OK, and with the sill height of 18 inches just place it. Yeah, and likewise duplicate again and call it 8 foot. Okay, and in that case the height would be only 5 feet. Apply and OK, and the sill height should be 3 feet. Yeah, that's fine, but the width should be 8 feet. Yeah, apply and OK. Let's just place it, and you can just align it and position it, and this is perfect. And this space should come on this interior side, so flip the direction, and here to flip the direction, and now just see it in 3D. And yeah, perfect, no issues. And so quickly and fast we created that particular entire, and just select it. With that selected, move from this point to this point. Yeah, and there will be a flower bed here, so again we need a small parapet over here at this point, and then we lay the flower bed. So let's do that quickly. And CS, or actually let's select this wall, CS, and plinth and unconnected, only up till 3 foot, and just pick lines, press space, architecture, floor architecture. We already have that flower bed. Yeah, beautiful. And height offset 2 feet 6 inches, and rectangle from this point to this point. Actually this point was supposed to be taken out, excluding the plaster line. And 3D, perfect. See, and I guess that we have messed up with the window settings. Oh, sorry. Yeah, so both of this select, or actually you can select turn by turn and just change its constraint to load level, and this too also road level. Yeah. Okay, so this is done. Only thing remaining is that you need to flush, modify, join and column. Okay, and so this particular columns will have the plaster layer since they are visible from inside. So wall, not wall, sorry, wall, column and column architecture. And where is that? 2 feet 7 inches by 1 feet 1 inches. Yeah, this is that particular size. Okay, and let's go to plinth and try to snap it. Yeah, so that will be, and this is creating a problem. I have a column on this side also, so let's just reduce its size to something like 10 feet. Apply and okay. Okay, and this column, if properly placed, let me just see. Oh, perfect. Modify, join and join. Oh, sorry. Join and structure with that. Yeah, so that will wrap the layer of plaster and all of that. Just CO and select this point and place it here as well. It didn't snap properly. Delete. CS and 1 and 2 and 3. Placing manually would save more time, I guess. So 3D and join this structural column with this. Same over here, structural column with the and structural column with this. Highlighted walls, structural column, join and structural column with why is it not CC, R enter and join. Yeah. Okay, so we have our office space perfectly created, no issues. And with the direction for this, not this only door. And here we forgot to place the door. No, it's there. Why is it not visible? Wrong work plane or what? No, it is there. Yeah, space. Yeah, okay. CCR enter. Okay. Only thing left for this particular floor is now what we need to do is that select all of this, filter and check none and say that structural framing. Select that structural framing, girder and other. Okay, let's select both of that, apply, okay, and isolate elements. Okay, great. So what we need to do is that onto this particular floor we have this beams. Sorry, let me go to front elevation. And yes, select all these beams, and with that, just copy to clipboard, HR, paste, align to selected levels, and onto first floor. Fine. So all our structural beams are elevated to that particular level. Okay, and before we join the geometries, why is this particular one wall? Yeah, get rid of the top offset, and also this particular wall. Let's take this particular wall to the designated level before we join the geometries. So top constraint is right now plinth ground floor, that will take to first floor. And yeah, just because we edited the profile in order to have that particular cut, so again we need to edit profile and take this line all the way till the bottom of that beam, snap to that beam. Okay, bottom of that beam, and yeah, fine. Okay, so now what we need to do is that apply the layer of plaster, also this particular one column. So TR, this is the continuous TR, and join this beam with the structural beam. Watch here, join the structural beam with this structural beam, and yeah, get rid of that particular beam. And what else? Yeah, this consideration I forgot, it's absolutely my fault. See, the problem is that this particular beam is at first floor, but if you remember, then we had elevated this particular floor height is at 11 foot. So there is a small glitch, and we will just solve it later. And of course there is a way, but right now let's just concentrate on the modeling part, and let's get rid of that particular, or actually let that beam, this beam be there. Let's get rid of that particular one beam, because this beam is anyway resting on the column. And yeah, so see this here, it is doing the job perfectly at this location. Only this particular junction, it's my mistake, sorry. Anyways, now before joining, let's just apply the plaster first to the beam. And if you remember that we have already that particular beam wall, so don't need to worry. And architecture and wall, and let me first select this beam wall 12-inch bigger for that bigger beams. And now just pick lines and pick, oh sorry, constraint, I forgot. The constraint should be plinth ground floor with the offset of 8 foot 5.5 inch, and top constraint should be first floor. And okay, that will make its unconnected height 1 feet 6.5. The half inch is for the plaster. And with that, now if I just pick, yeah, 1 and 2, 3 and 4. Okay, and here to a small, oh perfect. Now beam wall 9-inch 10-inch, I mean 10-inch, and then do the same thing for all the other smaller beams. And 1 and 2, 3 and 4 and 5, 6, likewise. Okay, this is done, and this also can. Okay, just change this, press space, yeah, that will acquire the space properly. Okay, now what, yeah, this I forgot. So just select that wall again and pick, and yeah, that will overlap, yeah, because here there is. So now let's start joining it, and let's start from this point. Modify and join structural column with the wall, and likewise this beams also I forgot to assign the layer of that plaster, and as soon as I do, let me pop up an error because there is a wall coming up till this point, so they will overlap. But as soon as I will join, that will Revit will do what happened. Not a concrete beam, sorry, and beam wall CS create similar, pick and pick this. Okay, and pick this, pick this, and pick this as well. Yeah, see, I said, but doesn't matter. As soon as we'll join, it will space and just invert. Okay, so there are a lot of geometries for us to join, so now just stay tuned for a couple of minutes because it's going to be boring for you, but we have to do it. So join, and first is that tab and structural column with main column, yeah, and in this case also tab and structure with, watch at this point while I'll select, and again this beam wall, main wall, beam, and this, oh sorry, selected the wrong wall, join and tab, beam wall, and this, yeah, perfect. Likewise first tab and the internal wall, and then the structure, and then the beam wall and the structure. Okay, but still at some places internal wall with the structure, yeah, fine, so not an issue. Okay, likewise at this point main wall with the structure, and then beam wall with the structure, main wall and beam wall, yeah, okay. Only thing is that beam wall with the structure, tab, why is it creating a problem over here? Accidentally we might have join, and that is one, but join and this beam wall, yeah, so you need to be very careful and precise while picking, otherwise you'll not be able to do the needful. Okay, and see, this particular portion is perfect, but we need to do the same for all the other, and tab, structural framing with the wall, and now I'll be real quick, because you have understood the concept. The only thing is that you have to implement it while doing it, and structural framing with the wall, and structural framing with the wall, yeah, perfect. And same here, structural framing with the wall, and at all position, all the locations, all the junctions and everything. Okay, Okay, and this too, and this too. This. Sorry. This too. Okay. Yeah, this is left. Structural framing of the wall. And this framing with wall as well. This framing with plaster layer as well. Here. Perfect. See the tenfold of problems you are going to face while doing this. So, but that's okay. That is how you learn. So don't worry and just keep on working and don't give up. Fine, and only thing left is to continue this particular portion. And actually, oh, here this guy is still left. Yeah. Here there is a small glitch. Okay, perfect. Fine. And what we need to do is that this is a bit a junction which we cannot manipulate, so just forget about it. And here this is left, so these are the regular beams, so select this CS declines. Oh, sorry, again press undo, and CS and declines 1 and 2, 3 and 1 and 2. Okay, and this is space. So this also, I guess, CS declines. Okay, join and tab structural framing with the wall, and structural framing with the wall. Oh, sorry. Join and structural framing with the wall. Structural framing with the wall. Yeah. At all junctions. Finally. Okay. Oh no, not yet. These two are left. So CS. Actually, we can just click this and not that, but and we can do what we can do is select this and from this point to this point, and that will snap. Yeah, and likewise for this beam wall, from this point till this point. Okay, perfect. See, so we are done with it, and CC and R enter. Why is this every time creating a problem? Oh, sorry. Join and join the structure with this. Okay, and this needs to be okay, and join, yeah. Fine. Layer of plaster is wrapping with one another, so not an issue. The only thing is that join and okay, forget it. This guy is still left. Join and oh, sorry. That is structural column. Okay. The only reason of doing so much of work for the double thing is that I want to quantify it properly. And whatever we'll quantify, I'll give the proof that whatever we are doing is also perfect. So you might be thinking that how to judge that whatever we quantified is proper or not. That also I will show. Okay, so far everything is perfect. Now only thing that this particular floor plate needs to be taken at this level. But before that, I would like to take the AutoCAD plan and see that what is the formation or the anatomy of the beams at that particular level. And yeah, just ignore that. Okay, so what I will do is that I will go to plane floor and take this AutoCAD plan and take it to first floor. Okay, and let's go to first floor and VG, import it, let's turn all of that to halftone, apply and okay. But we cannot visualize anything, so in order to that visualize, just change this particular view range and bottom to plinth floor and also view depth to plinth, apply and okay. And with this we can see. Okay, now this AutoCAD plan has a lot of things, so we cannot visualize it properly, so just go to VG and import it categories, and under that live project and turn off this furniture and this and sanitation, apply and okay. Wow, okay, it's better than earlier. And you see this particular will be the projection of the flower bed, and here there's the balcony. Okay, so what we need to do is that select this particular concrete beam and drag it all the way outside, and also CS, that is create similar, and just pick lines and pick this point, so that will create that. What you just need to do is that change its Y justification to right. Okay, and TR and join that with that. Okay, and let's see it in 3D. Fine, yeah. So see, so again this particular TR and this beam will join with this. Perfect. But that is anyway the flower bed, and if you just watch this particular floor plan, and you see this is just the parapet and the wall stops here. The wall stop at this point, and this is just the parapet which is extending for this particular floor. And 3D, and again select that particular CS beam wall and just pick lines and lay that here and here. Okay, and also here. This part that will overlap, but that's fine. You can just select that, and from this point, this particular point, you can drag it outside till this point. From this point to this point. Yeah, perfect. Okay, see, while working in Revit you can always work in 3D also. So join and structural beam with the wall, same here, and same for this as well. And yeah, so now we can take that particular floor plate to this level where we will have to manipulate that again. Okay, so let's just do that, and we are going to select the same floor plate and just copy to clipboard, align to selected levels, and onto that we'll say that first floor. Okay, wow. And you see that how beautifully that, and only thing is that we will have a different formation and different composition of the finished floor layers for this particular floor. So just select this, edit type and duplicate, and call it, and I would call this first floor public. Okay, and we will manipulate this particular structure later, but what first step is that I want you to make to understand the composition and formation of this particular floor plates at different level. Okay, so for that I would just like to take you to this particular section, and I would just take this section and flip it and just see. Okay, so if you just click this particular floor, see on this particular floor, this particular the floor this is resting on the raft is the typical flooring which has the brick beds for waterproofing and the different layers of sand bedding and mortar and finishing. But this particular floor plate which is laid on this particular plinth level is, as I said, just a layer of PCC. It is just a layer of PCC, and it will not be a slab casted, and it will just be a layer of PCC, and on the extreme, on the along the periphery, it will have the reinforcement, the coping. Okay, but this particular floor plate, when laid on this particular floor, first floor, that would be the ideal floor casted. Ideal floor of 150 mm, that is 6 inches RCC slab will be casted. Okay, so according to that we will manipulate the thickness of this and the layers of this, and I will go to edit type, and now we will edit its structure. The conventional 150 mm 6 inch slab will be casted, so this sand bedding will now be part of this upper part. So 6 inch, and that would be concrete slab. So concrete cast in place gray, that's fine. Okay, now this particular floor, this particular slab once casted will be confined with the boundary walls and also a slab above. So there is no point of providing a brick beds, the layer of brick beds for waterproofing, since this is not going to be affected by rainfall or anything, but the slab casted will be uneven. So to have a uniform surface, this layer will now act as the layer of sand bedding or PCC in order to have the uniform surface. Okay, and rest all everything will remain the same. And this plinth finish flooring I need to change, and edit and duplicate and call it first floor public, and just copy it, and under appearance, before duplicating, let me just place that material, and while going to appearance library, I'm just going to select this stone and this particular rectangular stone, and after that duplicate and give it a name first floor public, and change the styling to 10 feet, which doesn't have to do anything with the actual tiling, but just for the visual appearance, proper visual appearance. Okay, and fine, apply and okay. So now you see this is the conventional slab casted with all the conventional layers, that is, this is concrete, and then the sand bedding and the mortar, and which you cannot visualize the line weight. Okay, but if you just see, then height offset of 151 mm has been given. Let me just change UN and change the switch to millimeters. Okay, and modify and just measure this. So 75, so not 150, 75, and see 75, that is 3 inch of finished floor level. Okay, that's fine. The joint condition we will work it out later once we elevate the wall on the top of this. Then we'll once and for all, once at go, we will have the joint condition for everything. First let's complete laying that all the different floors. Now you need to manipulate the boundary of this particular floor, the slab. Okay, so edit boundary and just go to first floor, and let me just have a copy of this so we can use it again time to time, and just drag this point over here, and likewise just pick lines. And now I'll be a little bit quick and just try to follow, and we are defining the boundary for this public area. Okay, and yes, this will be the drop slab, wet area, and this will end here, and yeah, this will end here, and all this delete, and rest all this delete. Okay, and all this also will, we need to delete all of this, and herein we will have TR and join this with this. Okay, and pick lines and onto here, yeah, or actually here this point, TR and join this with this and this with this. Okay, and get rid of all this, we don't need that. Okay, so this particular boundary defines that public area, and just finish, and yeah, lines intersect each other. Do we have any leftover? Highlighted lines currently intersect. Please highlight them properly. I cannot visualize. Continue, and yeah, see, so little glitch always. Okay, don't attach. Fine, and okay, perfect. Yeah, perfect. Now the same floor, I will just go to edit type, and with all the layers same, I'll just duplicate and change the finishing material private and call it first floor public duplicate. Oh, sorry, I duplicated it the wrong way. So first floor and duplicate, and call it private areas. And while going to appearance, again going to library and flooring and wood, and this bench wood Java, I just replace that. And now I will duplicate, call it first floor private, and this so let's say that's 6 foot by 6 foot, and done. Apply and okay, apply and okay. That has changed, so let it be public. And with that flooring already defined, now let's go to the floor plan and say that architecture and floor architecture, and let's select that private that we just designed, and we will have it from this point to this, and from here till from this point till this point. Let's just take this here and just pick lines, pick TR and TR, and also pick here TR and TR. Now we need to get rid of this portion, so just split lines and herein just pick this particular edge 1 and 2 and this inside edge, and then define TR and have a closed shape, and that would be the private donut edge. And 3D. Okay, and went it wrong. 75 mm of offset, and plinth ground floor. Oh, we provided a wrong flooring to it. First floor, I guess. Where is it? First floor private. Yeah, this. So that will change its okay appearance and everything. Now we need to define the wet areas, which will have the drop slab in terms of that will flush with the beam bottom level. Okay, and onto that we will have the brick beds and the waterproofing layer, and also the space, the sunk slab in order to have a space for the pipelines to go through. Okay, so that would be here and here. So let's just do that. First floor, and again go to floor, and with that first floor private, where is it? Actually, let's select the one that we created for toilet on the ground floor. See, plinth ground floor level toilet, and we'll just go to edit type and edit, and this particular will be having a conventional slab 6 inch. That would be RCC. Concrete cast in place gray. Yeah, fine. And the conventional layers of brick beds, the size we will define later, and insert, and one more. All this should be finished. 1-4. Copy, paste and paste. Okay, everything will remain same, only this 20 mm of sand bedding after the brick bed layers, and we will have the variation of brick bed layers for this particular slab, but that we will decide later. And yeah, that's okay. Okay, apply and okay, and then just define that particular slab from this point. I guess this flooring was still here, so yeah, from this point to this point, this entire will be the sunk slab, and we need to get rid of this TR and TR, and also this close shape over here, and fine, just like that, from this point from this point to this point, and from that this is the duct, so we need to get rid of that duct. TR and don't attach. Okay, now let's see it in 3D. Fine. So you see, this is the sunk slab. If I just go to this floor plan and take this section, then let's see where that sunk slab appears. So yeah, so this particular thing needs to be flushed, so align this to this. Okay, now before we join, I just want to make you explain something. So you see that this is the structural concern, the exact solution of which will be given by structural engineer, but what I understand is that this particular beam is onto here, and if you just see this particular beam grid, then on this face this particular beam is flushed with the wall, but herein this beam is occurring here. So a structural engineer might give a solution wherein there will be a beam here, tie beam, and this particular beam will be shifted to this location, or I don't know exactly, but what we are going to do is that we are going to provide 2 pie beams in this case, one over here and one over here. Okay, and the same thing goes here, that this particular slab wherein the beam grid is here, we have this much portion wherein we are going to have a sunk slab. So what will it rest on? So this beam which is stopping here at this end needs to be extended till here, and here there will be two tie beams. Okay, and that will join eventually with this particular one beam. So couple of tie beams we need to draw for this wash area, and let's just do that quickly. While right now we cannot see this, but let's go to the ceiling plan of plinth ground floor, and yes, so we can see the wall but we cannot see the beams. That is because BG and S, structural framing, this category is always off for the floor plans, structural framing. So we need to turn on and apply, and with that now we'll be able to select the beams. So if I just hide this wall, then you see you can select that particular concrete beam. Fine, and onto that we need to provide the tie beam over here. But before that, I guess this particular floor plate, let's see it in plan, and this floor plate, okay, see in this case it is extending this wall, but this we have snapped it to the wrong line, so this will go till here. Okay, and just finish and don't attach, and then go to plinth floor ground and select this beam and say CS, and very important, this placement plane. Okay, so since we are in the ceiling plan of plinth ground floor, the Z certification is top, then select this first floor and pick lines and just pick. Okay, and pick here too, but both of the beams select and change the ZY justification to right. Okay, and that will go in. And now if I see it in 3D, yeah, see, so we have a flush at both the end. Okay, fine. What next is that this structure, whatever you are seeing, this particular structure, let's see it in section first. Yeah, so this structure right now, whatever you are seeing is in its unfinished state. For example, this beam has been provided the finished beam wall, that is the plaster layer, but this floor hasn't. So what we need to do is that select this floor and align and snap it to this point, and go to edit type and edit, and onto this insert one layer and just bring it down. Okay, and that should be essentially 12 mm of nothing but just a plaster. That material has been already defined by us, plaster. Okay, and now you can manipulate this particular layers wherein you want to reach up till this. See, this has been totally perfect, but now the brickbat layers should be such that we will reach up to this layer in such a way that we'll have just a one tile of difference. Okay, so what we need to do is that between this we should have only a one tile of difference. There is right now 284. So let's just give this brickbats an ideal, that is 275, almost 275. Okay, and just okay and apply and okay. And with that, if I just now align and snap to the finished layer, to the finished layer of this, then yeah, see, so that is perfect now. Not actually one tile, but 2 inch of difference. That is fine enough. We can adjust it in this particular PCC or mortar layer to reach it, to make it one tile difference. Okay, but this will be actually the situation and the section and the floor formation and composition as far as this toilet drop slab is concerned. Okay, The same thing applies to this part. See, now you cannot see the structure that has been hidden. Only thing that we need to join a couple of geometries, so that is fine, we'll do later. And also for this slab, see, for this particular slab, which here there is a glitch tr, and that will join with this. Okay, and finish, don't attach, and that too will go to edit type and have insert and down, and that will be finished to 5 and plaster. Okay, and 12 mm. Okay, apply and okay. And now if you see that, then you'll not be able to see the unfinished layer, and that pertains to all the floors that we laid. That doesn't, because here there is a plinth, so anyways you are not going to see this, but from now we have to consider that on that intermediate levels. So edit and insert down, finish 1 5, finish 2 5, and plaster. Okay, and 12. Fine, apply and okay. And you see that this particular thing has been reflected here too, since we had sketched that with one element. Okay, only thing is that you need to continue the beam over here, so that would be very easy. So just press tab, and actually we could have done that in the plinth ground floor plan itself. Yeah, so with that beam selected, structural beam, watch here, structural beam, and we don't need such big beam here. We can select a smaller size, 9x18. Yeah, fine. We turned that particular yeah, okay. So structure, and let's just select this and first draw that CS, and placement plane first floor, and pick lines 1 and 2 and 3. Okay, and then select one, press tab, select all of them, and just change this Y justification to right and change that to smaller size, 9x18. Okay, and just go to 3D and see. Okay, so perfect, no issues. The only thing that remains is the joint condition of this, and the external layer of plaster, that is this beam wall, should go here. But before that we need to work out the joint condition, and plane the ground floor. My god, we made the changes in the ground floor toilet, and that might have changed the composition of that to that particular floor also. Let's just check, and let me just take this section all the way here, and my god, sorry. So let's do this, that edit type, and just copy this, rename, and copy this and give this name first floor toilet, or wet area or toilet. Yeah, the toilet is fine, and just okay, first floor toilet. Yeah, so that will change its name here too. And now we can edit this and duplicate this and call this. Okay, so wherein we can change the composition, and wherein actually we will not need the sand bedding, since that is already resting on ground here, and we will need it here, and that layer should only be 3 inch. Okay, and brick beds is also, yeah, brick beds will be provided, but this particular layer we need to delete, and brick beds will only be 44, so that will round it up to perfect, and apply and okay. Yeah, and we have achieved finally only one tile drop, and this layer is perfect. Okay, but also in this case we need to edit and get rid of this, because that would be underground, so we don't need to provide the layer of plaster to it. And now the layer is flush. Okay, so see, if you are working with Revit, then things are easy. Okay, and the joint condition is left, but before that, what I would like to do is that first is I want to finish this particular three parts, that is the three parts which will be affected by the external rainfall, that is this pathway and this two balconies with the flower beds. So we will use this same composition, same composition, wherein we have the slab flush to the beam bottom, and onto that we will have the finished flooring layers of this. Exact size again would be decided by the structural engineer, but conceptually it will follow this same strategy, and only thing that the finished flooring layer will be different. Okay, in all this one, this 1, 2 and this 3. Okay, so let's just architecture and floor architecture, and first let's define. So, and would not affect that. So here is the first floor toilet, yeah, and edit type and duplicate it and call it balcony, first floor balcony pathway. Okay, fine, and that would be okay. And just edit, and all this layers composition will remain the same, only this finished flooring will be changed, and that would change to duplicate material and asset and call it first floor balcony pathway, the same name, and just select it, copy, and don't duplicate, first apply the material, and that would be, actually we can just browse from here and press S, site work, and yeah, this I want to give this particular material, and okay, and 1200, or let's enter 4 feet by 4 feet. Done, apply, and okay, apply, and okay, fine. So that is defined now, and go to first floor and then just draw a couple of rectangles, and here the needful will be done. And here too, from this point to this point. Okay, and height offset minus 12 inch, that is 304.8, automatically it will convert, no issues, and finish. Highlighted floor overlaps. Okay, let's just check in 3D. It didn't even create. Where did we create that? Plinth, ground floor, and first floor, and floor architecture. Yeah, fine. So what is your problem? So just edit boundary, and let's see it in 3D. Do we have any floor there? No, we don't have them. Right? Overlap. Okay, first floor, and yeah, also this pathway, this particular pathway we need to consider. So rectangle and all of that here, and from this point to this point, and just pick lines and snap TR and TR and join this to this, and hopefully, fingers crossed, yeah, just don't forget this pathway, because that is also going to be affected by the external rainfall by the semi-covered pathway. So TR and want every one of them to join at beam bottom. Here there are beams, yeah, fine, let's just don't attach. And 3D, yeah, absolutely perfect, no issues, fine. This finished floor level is, yeah, so we need to check it in any of the section, and let's take this section over here. Oh yeah, see, so we need to flush the edit line and this finished level with this finished level, and all of them will be perfectly positioned to its desired location, designated location. And okay, great, fine. And I think that for this particular we need to edit boundary and add that puja room, which we forgot to. So while in the sketch mode, just select this rectangle and pick lines TR and TR and just finish, don't attach. And also this particular floor plate, where will this particular flower bed rest on? We need to check it on 3D. Yeah, here there are beams, so they will extend the reinforcement and create one, so it's not an issue. It's just a simple flower bed floor plate we need to create, that's fine. You don't need to provide drop trap for that, and just so much of. We are going to create here one, so at that time we will create. Okay, fine. So next is this first floor and this particular floor plate, this flower bed, and with that we will create this also. So architecture and floor architecture, and that would be this flower bed, but that is just 1 inch provided for first floor flower bed. Oh, already defined. Did it type in grass? Where did I lay that on first floor? I didn't. And let me see, I have provided that somewhere. 3D and floor, and flower bed, delete. Oh, 4 instances will be deleted. Where did I provide that? Okay, yeah, that is okay, I got it. This particular flower bed it is talking about, so that that we cannot use it here, so we need to create one. Fine. So first floor and floor architecture, and this pathway only we will edit, duplicate, and call it first floor flower bed, and that would be conventional slab only, no issues, but we won't have so much of waterproofing and so much of the layers. This finished floor layer would be just grass after the soil filling, and that is again technical matter, but doesn't matter, just provide it a layer of 5 mm, that's okay, or 12 mm, that's okay. But this mortar will not come, sand bedding will not come, brick beds, yeah, that will come, but I don't know how much. So right now just provided a 50. Okay, and okay, and apply, and okay, and just create that one, and from this point to this point, and tr, and take this line here, tr, and join this with this, and just get rid of this line. Likewise, create pick lines and create, yeah, that overlapped with the external point. This will come here, this will come here, fine, and tr, and join this to this, and yeah, here we selected the outer edge, so not an issue. First floor flower bed, yeah, fine, okay, finish. And tr, and join this to this, finish, finish. Continue, and drafting errors now hopefully come out, and 3D, and yeah, so see how perfect. This beams, yeah, okay, so just like we created the tie beams over here, we also need the two beams onto this particular edge. Okay, so that is not an issue. HH, and what we will do is that go to the ceiling plan of that particular floor and just pick this, press tab, and VG, and structural framing, it's on. Structural framing, yeah, that is on. Then press space. HH, and yeah, so okay, fine, so no issues. Just select this and say CS, and with that, placement plane first floor, pick lines, and Z justification top 1 and 2 and 3. Okay, so that might have done the needful. Oh yeah, okay, only thing is that 1 and 2, this should be changed to left. Okay, and fine, and only thing is that we need to provide it the layer of plaster. Again, need to wrap. Joining geometries is still left, so that is the next step, but first is that I want to have this a proper finishing. So what we will do is that this is which wall? 9. Okay, so wall, and this time we'll work in 3D only. Beam wall, and first floor, top constraint, no, so plinth ground floor, and base offset 8.5.5 inch in order to get rid of 8 foot 5.5 inch, and the top offset should be the first floor, so unconnected height, yeah, fine, and with that just pick lines, and 1 and 2 and the last 3. Okay, and just select 1 and press, oh, I don't want other, please don't give me that ugly sound. Press select one and press tab and select all of them and just space. So that will acquire its space properly, and HR. Okay, so we are done with all this, and the last part remaining is this foyer. That would be interesting. And see, we forgot to draw the flower bed over here. So just select this and edit boundary and simply go to first floor and create that 1, 2, 3. TR and TR and TR. These are actually till here, all the way till here. So 1, 2 and 3. Okay, so TR and TR. And one onto here also. 1, 2, 3, 4, 5 and 6. TR and join this to this, this to this, this, and TR join this to this. When in lines overlap, it gives that ugly sound. Revit. Fine. And with that, just finish. White highlighted lines. TR join. Yeah, see, just like that. So just join this to this and split lines, and then join this with this, and join this with this. And 2 lines. Don't attach. And 3D. Yeah. Okay. Fine. So we need to provide a small sliver of parapet over here, but that's okay. That can be considered. Fine. And first floor, and this foyer needs to be created. So again, we will create one floor architecture, and that would exactly have the same formation of this. So first floor, public, and edit type and duplicate and call it foyer. Okay, and edit type and just change the finishing material and apply it a material of the one that we provided down. Finish floor public. Yeah. Just provide it. Yeah, we provide it. Okay. And just say okay, apply, and okay. And in that drafting mode, if you remember that we have already taken the copy of that footprints, which we are going to use now, which will reduce our work a little bit. Okay, and join this to this, join this to this, and this to this, and just get rid of these lines. And okay, pick lines, and pretty much easy that was. TR and join this to this, and yeah, rest everything is fine. Okay, so delete. Delete. Where is the problem? Lines must be in closed loop. They are. Where is it open? We need to forget the delete this. and just finish and don't attach, and 3D, and forget about the height offset because this is not having any offset. 75 mm, yeah, fine. So give it 75 mm and that will flush. Perfect. Oh my god, with so much of work we have been able to, and this actually will edit boundary and HL and just split this line and TR. All the geometries are anyways going to get joined, so don't worry. Don't attach and R enter. Fine. So with that we have successfully created, what is this? And let me just go to basement level, basement slab. What is this column doing here? We might have placed it by mistake and still remains. Then ground floor and delete that, and first floor also we have water of that. Okay, and 3D. Okay, so with that we have successfully been able to create the flooring part for this first floor, and this still needs to be okay, forget it, we'll do that later. Next step is to check out the joint condition of this particular laid floor plate, that is the slab, casted slab, and its joint condition at various junctions with the column and with the structural framing, that is the beam. Okay, and we won't be able to do it for all the junctions, but for few junctions and the quite evitable one obvious junctions which I need to show, I will just show you the concept and fundamentals of that, and then rest you can just complete it. Okay, so while in this particular floor plan, let me take this section. Yeah, it is at the perfect place, and let me just go to the section, and yeah, so see, the first evitable is that the last floor plate of flower bed we laid, we didn't took it to the desired height and desired location, and this finish layer should flush with this. Okay, and the joint condition I will come to it later, but this is again a problem. So you can see that this is incorrect. So again I will need to go to the first floor and just select this particular floor plate, and yeah, see, so this isn't, so this should come at this point, and we have the beam projection on this end and flushed at this particular line, and projecting out at this end, and this particular line is all right. Okay, don't attach, and with that let me just select this also and edit boundary. So this will go to this point and this will go to this point, and here we have the beam projecting going on this particular alignment in this direction, so that is not a problem. So we will have a flush face, but this particular beam is projecting out. I'll just make you explain, don't attach. And if we just go to the section 1, yeah, see, so this joint condition is proper, the joint condition of slab is proper, but what you see is that here there is a 4.5 inch wall, and that's why this line is stopping here, but that will be rectified when the walls is placed, and I'll show you that how. Okay, and this is flushed face. Fine, so no issues. Now first is that I need to turn HH and join these parts. So join, and now it is very important, so just pay attention because this is really tricky and confusing. and sometimes it might work and sometimes it might not. You'll just watch, you'll see that you'll witness that while I am working, I'm also working, I also face a lot of problems in this. So just watch this point, okay, and just pay attention to my words. So select this structural framing here. Right now it's saying that beam 10-inch wall, press tab. So structural framing with the structural framing, floor with the press tab, and yeah, see, so the structural framing is joined, but what we need to do is that join beam wall with this, okay, and again join and join geometry, and yeah, the structural framing is joined, only we need to switch order and select this and select this, okay, perfect. So this is how, again you can see this wall hatch, so that means that join geometry, and you need to select the beam wall and the concrete portion, and yeah, so see, we achieved it with several clicks. And this is the layer of that particular plaster that is wrapping around this particular beam. The same way we have a join condition here, that is join the structural element. Watch this point, structure concrete beam with the floor, okay, and join this to this, and then join and switch order this to this, okay, and we have the perfect join condition, okay. So here, as soon as you will lay the wall, this particular, and after laying this wall, when you join, so this particular finished floor layer will go inside. I'll just show you when the point comes, okay. Now the next part is turn HR and the join conditions of this. So again join and join this particular floor with this, yeah, perfect, fine, but still the structural element needs to be joined. So structure and this, yeah, absolutely perfect, fine, and also onto this face, so structure and structure with the structural element, yeah, and again we have this beam, this to this, yeah, and see, perfect join condition, okay. Now this is going to be a bit tricky. So first is that if this beam is going to get embedded in the sunk, then we don't need to provide it the beam wall, that is the layer of plaster. So the first step is that go to the reflected ceiling plan of this, and we cannot select it, so just select it and press tab and select this beam wall, and from with that select it, just go and take it from this point to this point, okay, and then again going to section 1. Now we have just this concrete which needs to be joined, but as soon as you will join this concrete with this, then the beam disappears and we don't have any reference to snap to. In order to switch the order, what will you snap to, okay. So now again there is a trick which needs to be followed, and let me just click, and this level line I need to press HH and hide it, we don't need to see it, okay. So now in this case, what the trick is that you have to select this floor, go to edit type, edit, and onto this the brick bed layers was 275 mm, just reduce it to 200 mm and make that particular concrete beam visible, okay. Align and align this point to this point, okay. So now you can see this much portion, so you can join and join switch order, and this is the trick, okay. And once done, you can again select this particular thing, edit type, go to edit and 275 mm, okay, and apply and okay, and with that just align and this with this, and you have your perfect beam embedded with all the finished floor layers visible. and see, this is the exact join condition. This is how the beam will join to the slab and that to the finished floor levels. Okay, and why did this again this particular thing is creating a problem. Here it is all right. Here I guess that switch order and this with, yeah, perfect. So this is the way the slab will join with the beam and the finished floor layer will go up, leaving the structural elements behind. Okay, fine. Now let's start from here, and now it's going to be pretty much easy. The hardest part was done. So join this with this and structure with structure and join and switch order. Join and switch order this with this, but I made a wrong connection, I guess. So the first control Y, yeah, fine. So the first step is that join and select the concrete beam structural framing and connect it with this. Okay, once done, join and select this particular layer of plaster and join it that. But again, this is creating switch order and this to this. Yeah, perfect. Okay, see, and press tab until I find this AutoCAD plan and just hide it, and yeah. So see, this little sliver the plaster layer is that if you have a wall over here, and if this is the layer of that wall, then that will go up, and see, and this will be the join condition. And the same thing was here that I was trying to make you explain, but this doesn't have the layer of plaster because it's embedded, so there is no point. Anyways, that is the beam. So okay, but that I just wanted to show you. Okay, and again join and join this with this, switch order, and oh no, sorry, join switch order. Still this needs to be joined properly. Okay, wrong connection, and you need to be very careful. Join and watch here, structural elements, structural framing with the slab, and then join and join this geometry. Okay, and join and switch order and take this concrete beam and take this. Yeah, fine. Okay, so this is the perfect join condition. And then finally join geometry and select the walls first, or sorry, the structural framing first, and tab structural framing with the wall. Yeah, and then this with this. Okay, and join and switch order. Okay, but this needs to be joined. See, this is what happens, and you need to be very careful. So join geometry and the structure with, you have to try multiple options and you have to try joining it multiple ways. That is the only way out. And then join and join this to this. Okay, and then join and switch order, actually not switch order but join and select this structural tab. Yeah, so done finally. Okay, there are a lot of guessing games in this, but sorry guys, that is the only way out. The Revit it follows some system and methodology, but sometimes it is difficult to crack that, so you have to do it again and again. That is the only way out. Switch order, and yeah, see, and join this with this. Okay, and this time at first go only I had it. Okay, and this part will be visible, so let this particular structure, this plaster of layer of plaster be there, because if you try to eradicate this, then it will exclude that from the entire face. Let's just try. Oh no, that worked. Okay, only that is going for this. Great. Okay, and that is the perfect join condition. And you see how much time did it take to join this one junction, and likewise we have so many, so it will be difficult to cater to all, but let me try how much can we attend. Let me just take this here, and now things will be easy. Okay, and then this particular first, so join and select that structural framing and join this with, and then again the guessing games, switch order and this to this, yeah, and join and this. Okay, worked. And finally, and this structure with this, and then join and this, yeah, and wrong, so join and join this with this, but this I guess didn't work. Yeah, did. Perfect. And join and this to this, and that was easy. And what else? To here, this is done. Okay, this would be easy. No issues. Join slab with the structural framing and then join this, and just join and switch order and this with this, and the job is done. Perfect. And slab with the join and slab with the structural framing, and then this with this. Oh, easy. And switch order. Oh no, sorry, join and yeah, that's join, but we need to join this to this. And yeah, somehow it is creating a little bit of glitch, so again undo and join this with this, and join and switch order. Yeah, and join condition in Revit is really tricky and difficult. Okay, perfect. And this, yeah, this is complete. No issues with this. And now as soon as you go on completing the junctions, things will start getting easy, will become simpler. And now this junction, and actually let's take this wall as well, and this doesn't join, and this to this, and switch order. Okay, and join this. Sorry, join and join and switch order. Join and then this to this. Undo. And yes. Okay, join the structural element, structural framing with this, and then join this to this. Okay, but then this is join switch order. Okay, and join this with the structural framing, with the slab, and join switch order. Perfect. This is, yeah, this is that lift shaft, so you don't need to worry about that. And structural framing, with this wrong, and it's this side. Join and this with this, then join this with, okay, and forget about this, not much important. And which part is this? This seems proper, I guess. Yeah, okay, no issues. And on the first floor, I guess on the parking level everything is perfect, and we have done it perfectly, so we don't need to worry about that. But this part on the first floor is this, which has a cutout. Yeah, fine. And this, yeah, this is the puja section. Okay, so okay, join and join this with this. Okay, that was easy. And this is perfect. Only thing that you need a beam over here, but forget it now. I don't want to go in much detail, otherwise the rest of the modeling part will be left. And this junction, okay, we just did it. So, and now this particular, and this is again going to be a little bit confusing, so just pay attention and join. A lot of guessing games, the structural framing with the slab, and once done that, we are going to use the same trick, that here in edit type and edit and reduce this to 150 mm. Okay, apply and okay, and just flush this in order we can see the line, and align this with this. Okay, and just join this to this. Oh no, sorry, wrong step. Join and this to this, but join and switch order. Yeah, perfect. And then join this with this. Okay, and this wall actually will not go up only, so there is no point joining. This wall will actually stop here. So let's say that plinth floor and unconnected height, that would be 8 foot 6 inches, or yeah, 8 foot 6 inches. And if we want, you can join this, cut the overlapping volumes, and this join, and again being with this, switch order and join this with this. Okay, perfect. And now again the same trick here, edit type and just change this to 200 mm. Okay, once 150 mm. Okay, apply and okay, and then align and align this point and this point. Okay, and then join the geometries, and this with this, and join and switch order. Okay, and join this with this. Perfect, absolutely perfect. And join this with this as well. Okay, done. And now with that, just take this back to edit and 275 mm, and that will pop up an error because this particular thing will have the overlapping volumes. And apply and okay. Oh, didn't, But once we align that, maybe after that, align and align. Yeah, see, one completely is completely in, yeah, that's fine. Okay, doesn't matter. But the point, what we wanted to achieve, we have done that, so not an issue. Yeah, the error popped up saying that this particular element is completely under this, but that's okay. And HH, and yeah, fine. This is exactly what we wanted. Only thing remains is this to this, and absolutely perfect. See? Okay, and let me just go to plane floor and just take it here, and that is perfectly joined, no issues. Okay, so this is the fundamentals and the basics of how to join different geometries with different disciplines and different layers. Okay, and how to wrap them with one another in order to get the proper joint connection in order to properly schedule and quantify it. Now you just saw that if I just imagine that if I just do that for every horizontal ones, then how much time it will take. So you just do the needful, and now let's further continue with the modeling part, because this is really taking a lot of time. My point was just to show you the basics of this, and which I guess that I have already shown. So now you can just complete it, and now let's start taking the walls. Okay, and you see that this particular one wall will not come. Actually this wall will not come only, so why did we missed it? Okay, so join, and let's say that join and this, and join and switch order. Join and switch order. No, fine. If we're just doing, then let's do it properly. And this particular section, yeah, and this wall should not, this should stop here. Unjoin, yeah, fine. Fine, and join with this, yeah, perfect. Okay, no issues. So that was pretty much simple. Okay, so you see that a lot of junctions, it is not possible to cater to each, but this is the fundamentals which I have cleared. Okay, so now let's continue with the modeling part, and let's take the wall above this. And for that purpose, the first step that follows is to take all the structural columns to the floor above, the level above, sorry. So filter and check none and say that structural columns, apply and OK, and with all that selected, the base constraint might vary, but the top constraint is right now first floor. Just take it to second floor. So with that, all the columns are taken to the floor above, but I guess that we actually don't need this 1, 2 and 3 columns, so let that be at first floor only. Okay, and with that, only these 2 columns will stay exposed, rest all will be embedded in wall, so we don't need to add the layer of plaster, and things will be easy now. So just select this particular round column and this, and change both of that to second floor. Okay, so the layer of plaster is wrapped for those 2 columns. Okay, so now we have to start the modeling, and for that let me just go to first floor, and yeah. Okay, so now, oh yeah, for the one thing more, we need to take this tab and control, hold that and press tab and select all of that and take them to second floor as well, the lift shaft and the stair cabin. Okay, now we have to start with the modeling of this particular full floor, and for that we will start with here. So what is 9 inch? Yeah, fine. So architecture, and WA is the shortcut wall, and where is our main wall? 9 inch. Here it is, and just change this constraint third floor, 3 first floor, and top constraint second floor, and just start from drafting from this point to this point and this point, and actually this will continue till this point. And WA and internal wall 4.5, 4.5 inch, declines, and location line finish with exterior. Yeah, fine. We will adjust it later once we are done. Okay, and this 2 is the internal wall, I guess. 1 and 2. Okay, and space, space, and space. Okay, everything is perfect. Only this wall will go till this end. This end. And now again CS, that is create similar, and from this point that space connect to the endpoints, and okay, all these walls are drawn. This will be a parapet, a 6 inch RCC wall. So let's start from here, and this space, this point, space, and just click here. Okay, and from this point to this point, and from here till here, and just pick lines. Flip, and likewise CS, CS, and from this point to this point, pick lines, and TR, and connect this with this. Then what will this particular one column do? Okay, forget it. We will just attend that part, and select this, and CS, create similar, pick lines 1, 2, 3, 4, and 5, space, delete, and CS, pick lines, and you snap to the wrong line, that's why. Okay, and space, join it here and join this here. Okay, and this will be the parapet wall, TR, and CS, but this time change the constraint to unconnected and only 3 feet, 900 mm, and just pick. Okay, fine. Now this is the assumption that this particular wall is on the south facade, and this is the box wall created, and the special wall which will be created in Revit, and Revit has an ability to create this wall also. So just let's see, modify, and measure 9 inch, and this is the cavity of 10.5, and this is 4.5. So in total this should be 2 feet. So including half inch of plaster on both sides, it should be 2 feet 1 inch. Okay, so WA, and edit type, and duplicate this, call it south wall, just an assumption, and edit. Herein we are going to add 2 layers, of which this plaster layer will go on the top. This would be air, thermal air layer for cavity, and air is already existing material of Revit, so add that. And this would follow the same wall paint, but the thickness will only be 4.5 inch. Fine. And the plaster layer on this side, so in total it makes, yeah, but the air layer needs to be 10.5 inch as we measured, and see 2 feet 1 inches. And at inserts, say that both, and at end just say that exterior layer should wrap. Fine. With this, what happened? Layer function priorities cannot extend the core boundaries. Yeah, so this shouldn't be structure 1. Structure 1 should always follow between this core boundary. Finish 1.4. okay, apply and okay. And with this first base constraint to be first floor and top constraint to be second floor, let's just draw that wall and see that core face interior exterior doesn't make any difference. You can always flip by spacing the space. And with that, you see that we are drawing a box wall. Let's TR and connect with this. Wow. Okay, so we have entirely drawn that particular box wall. Fine. CS create similar, and no, but that is just, this is 6 inch per the, I guess. Yeah, so select this wall CS, and from first floor give it an unconnected height of 3 feet, from here till this point, and from here till here, and here till here, and this point to this point, and TR, and this would be the parapet. So no, but that we have already added the beam, so fine, that's okay. And this we need to construct. So again, CS create similar, pick lines 1 2 3 4 5 and 6, and just tab and say that no, you cannot. So just click individual and click space, and AutoCAD curve and Revit curve will never match, so that is not an issue. Okay, this will be puja room, but for that I am going to define a different wall and just call it puja room wall. Just a different material that would stand out, and load bearing wall, and yeah, we can provide that material, I guess, exposed brick, and paste that. Okay, and okay, and apply and okay. Fine. And there will be a parapet here and here too, so that would be again just CS, and just from this point to this point, and space this point here to here, and this point to this point. Perfect. Okay, fine. So CS and pick lines and Why is this one guy floating like this, hanging in the air? Basement slab. And where is the AutoCAD plan? Do we have a column there? No. So by mistake we might have added that. Just select it and delete it. Basement slab, and just delete that. And also check on the plinth ground floor whether that, yeah, see, delete. Road level, yeah, okay, fine. And with that we have successfully laid the walls for the first floor very quickly. That's this 3D. Fine, easy. Okay, next is that now all these columns are wrapped, but there are few columns purposely done that ways that it should project out of the core structure, that is wall, in order to show the joint condition of that. Okay, so, and why is this one column? Yeah, this is actually the grid. This is part of grid. So what to do? We cannot discontinue it from this level, so let it be, fine. So before joining the columns with the wall, first I want to add the structural grid, and then we will add the layer of plasters to the extruding structure part, and then we will add, and then we will join. Okay, so again what I need to do is that select all of this and filter, check none, and say that structural framing. Okay, apply and okay, and isolate category. Okay, so the same will go above. So just copy to clipboard and HR, paste, align to selected levels and to first floor. No, not to first floor, second floor. Okay, beam or braces slightly off the axis and make it all clarity, not an issue. Okay, so the structural framing has been taken to that particular designated level. So now we need to tally this with the AutoCAD plan, and this beam will not come here, this will stop at this end. Okay, this junction is not yet worked out by us, that will attend later. And by going to first floor, let's just take this particular floor plan and take it to second floor, and now enter the second floor plan and VG, imported categories, halftone, apply and OK, and we have all our modeling here. So again we need to shift this, and again a base point which is common, and this is that. So align this with this and delete. Okay, and with this view range, let me just check, and road level, not road level, first floor, yeah, and just select this particular AutoCAD plan and HH hide it. So yeah, you can see that it's properly positioned. Fine. So now we need to go to 3D and make some changes as far as the structural grid is concerned and everything. Okay, so what you infer in this is that first, this structural grid for some portion needs to be avoided. Okay, so what we will do is that, for example, if you just see the floor plan of this, then this particular floor plan, that is the second floor, will just have at 23 feet, this will just have a balcony, and this flower bed will be a double height portion, and the same is in the case of this. Okay, so first we need to decide that what will be the structural part that will be extruding out. So we will add the plaster layer to only that part. Okay, so let's just select this and isolate category. And first is that this beam needs to be shifted at this point. Highlight elements, yeah. Oh, I guess that we missed, and this should go straight and a little bit more. Yeah, fine. And this beam will stop here, so just TR and finish that and delete this. Okay, let me select this and HH, so that might not confuse you, because I can grab but difficult for you guys to. And also this beam will not come, so delete that. Okay, not delete but modify and split element, and just pick this, split and join this with this and join this to this, and so now we can delete this. Okay, and let me just press HR. Yeah, fine. So what left is to add the layer of plaster to this exposed structural elements. Fine, so let me just click this and press tab, and this is the main wall, but I'm looking for that beam wall. Which wall? 10 inch, so WA, and that beam wall 10 inch, where is it? Yeah, and just say that not unconnected, but let's change its constraint to again 8 feet 5.5 and half, and this to second floor. Okay, so the unconnected height will be 1 feet 6 inches. Fine, and just pick this, and yeah, there will be double counting of schedule, so we need to pick this point and drag it all the way to. Wait till this dotted line pops up, showing that its alignment is exactly 45 or 90, sorry, not 45. Okay, and with that, still this is not in place, so let's press undo, just shift it, that will not be aligned properly, undo, and if I just press, yeah, so with that you can just go to top elevation in here only and just drag this point to this point, so we don't lose the orientation, and wait for the end point to pop up in order to join that. Fine, and here to CS and pick lines, and double counting of schedule, highlight wall overlap, doesn't matter, we will properly position them to avoid double counting of schedule. Why is it adding like this? Move and move from this point to this point. Yeah, perfect. Same way, all this exposed structure needs to be taken care of. So why is this? Which is correct? Press space, space. And so with that selected, just change this white justification to left, and that will properly place that. Okay, so we need to do that for a lot of structural elements. And okay, this is so where is that? Yeah, see, beam wall 10-inch CS, and pick lines, and with this pulse constraint same, let's add it here and here too. Okay, and this particular portion, I think there is a problem here, so we will attend that later. CS and pick lines, and with the same constraint. Okay, and this too. No, these are the bigger beams, and why is this gap? This was that same beam, but here there is a glitch. So the glitch might be, according to me, join and switch order, and this to this. Yeah, done. But these are the bigger beams, so we have to select WA, and for beam wall the 12-inch wall, and pick lines, and then with the same constraint, that is this same constraint, just pick 1 and 2. It will highlight overlap, I guess. Yeah, see, overlaps, that's fine. We will just, and here to that will space and overlap. Yeah, again overlap. Okay, no issues. And this beams are the smaller beams, I guess. Oh no, they are the same beams, so this would also have the same CS, and pick the center and pick the center. Yeah, okay, so here to CS. This is an odd junction. I might be incorrect at this place, but what I understood I did. Yeah, okay, and this one is left, and those are the regular beams, I guess. So again WA and beam wall 10-inch, and pick, snap to the center. Not snapping, so 1 and 2 and 3, and this 1 and 2 and this 3. Great. Okay, and just select this and change, press space. Okay, what is left is that you need to trim this. Press tab and select the beam wall and this beam wall. Yeah, okay, there is a small glitch here, but that we will rectify, don't worry. And that is because this needs to be properly positioned. Go to top. Yeah, see, so there is an error, and 0.5 inch. 0.5 inch. Okay, and this also needs to be shifted 0.5 inch, and this also needs to be shifted 0.5 inch. Enter. Yeah, okay, so we have perfectly joined that, no issues. The only thing is that now we need to add the layer of plaster to this 1, 2, 3 and this 4, this columns. So do we have that down? Yeah, so the trick here now will be for the for the extruding columns. What trick we will use is that we will just select this exposed concrete material. Watch here, and 1 and 2 and 3, and this 1, 2 column also we need to select. So just select this and this. Okay, and which other, this 2 circular columns. So just select this and this. Make sure that you're not selecting the structural column but the finishing plaster layer that we have applied. And with that selected, just copy to clipboard and paste, align to selected levels, and just bring them on first floor. Okay, beautiful. And after doing that, they are not the exposed columns, so what we need to do is that select 1 and 2, 3 and 4. Let's hold the control key, and with that 4 columns selected, this is exposed column, so let that material follow. But with this selected, just change it to 2 feet 7 inches 1 cross 1. That is the normal plaster. Fine. And this 2, 1 and 2, and change them to round column, simple 24.5, which is having the plaster. Okay, and here last thing left is that we need to create this 2 exposed beams. So in that case, what we need to do is that select this beam wall 12 inch CS, and that will pop up an error that highlighted walls overlap, but doesn't matter. 1 and 2. So with that selected, 12 inch, so we need to change it to 10 inch. Yeah, both of them 10 inch. And with that selected, just you can bring this, but you will not be able to snap here. So the trick again follows that we need to snap it from this point to this point, and this wall again from this point to this point. Oh, perfect. So fine. Okay, and the only thing left is everything is done. Fine, everything is done. Yeah, this is remaining. Okay, so again, let me just properly visualize this. Why is this beam still visible? Second floor, and let me just take this section here, go to the section, and we did hide that beam then, right? Oh, so in the quest of designing that, duplicating this and designing the floor for the ground floor, let me just show you here. See, we duplicated, and here there is a toilet on the plinth level. So in order to duplicate design this, we duplicated this, but here we forgot to change the constraint. Yeah, fine. So let's just do that, and with that just join this. Okay, perfect. Join this, join and switch order. Why is this layer of plaster not wrapping? Switch order. Okay, it is wrapping here, but somehow due to some reason it is not wrapping there, but that's not waste time. And this particular floor, this toilet, first floor, edit type, edit, and yeah, see, so this needs to be 275 mm, so that will hide the beam. Align, okay, and just align that with the finished floor of plaster line of this with the plaster line of this. Okay, perfect. And now if you just take this particular section to this point, then that would be perfect. Yeah, see, and even in 3D you won't be able to visualize that beam. So see, that beam has been gone. Okay, and this flooring actually needs to be grass, but that will do it later. Fine. Right now what important is to, and let me just go and let me just take the vertical section in order to The position of this beam is incorrect. That will actually follow from this point to this point, and from here to this point. Move again, and this point. Yeah, and now see it. Okay, here it is perfect. Okay, a little bit of glitch. Yeah, this vertical plaster onto let's go to the ceiling plan of plinth ground floor with that selected. Yeah, just take it, hit this point. Perfect. Okay, but this beam is section 5. Yeah, it is proper. Yeah, but this beam needs to be shifted. And flush this face with this. Okay, fine. So now in 3D that would appear proper. Yeah, perfect. Okay, and this is, as I explained, that this particular column has the flushed, this particular beam has the flushed face. So here too there is some problem, I guess. Let's see it in section 1. See, this wall has, yeah, so just enter the space, though that I don't know, but accidentally this wall has changed its orientation. So just select this wall and press space, and likewise see this. This is proper. So we have the beam extruding onto this wall. So this line is flushed, but herein this particular line is flushed, and this is the extrusion which you will be able to visualize from room. So that we need to hide. Okay, and that also wouldn't be big issue. So just select this and CS and select this, and with that same constraint just pick this. Okay, and also herein pick this, and as soon as you'll select this and press space, that will pop up an error that highlighted wall overlaps. Yeah, that's fine, because we need to join that. Okay, so a lot of geometries to be joined, but at least we have covered the plaster layer. This wall, this columns are still visible. Why is that? Yeah, they are the bigger columns. So just like this, we need to, so again go to the second floor plan, and we have a lot of lines we cannot visualize. So let's just turn this range level to none, so we can apply, but we cannot see anything on second floor. Why is that? Undo. Yeah, how will we be able to see on second floor? On second floor we haven't elevated anything, sorry. First floor. Okay, yeah, so you see that here there is a column perfectly flushed rectangular column. So Control C, and this view gives a better view of, better visualization of our stuff. Yeah, 1 and 2 and 3 and 4. Okay, perfect. And just watch it in 3D now, and yes, everything is done, but something always remains. So CS, and with that same constraint, pick lines and pick this. Oh, sorry. Undo. And what are the constraints? Oh, we selected the rectangular beam. So this is that beam wall. CS, pick lines, and yeah, so okay, 1 and 2 and 3 and 4, but just select all of them, press tab, sorry, select one and tab over your mouse, tab. Why is that not selecting? Anyways, that will pop up warning message, highlighted wall, that's okay, sorry for that. Yeah, so with this we are completely done wrapping the entire, all the walls, all the structural elements with the architectural elements, wrapping it with the layer of plaster for each and every junction and each and every structural 3D element. Okay, the only thing remains is now a big task to join them. Okay, so let's do that quickly. First is that we will join all the architectural elements, that is architectural beam and architectural column and the wall in this particular portion, this entire portion, because here if you see that the beams and the columns, architectural part, everything is flushed, but herein there are the larger beams and the columns, and to apply the layer of plaster that has created niches and it's projecting out. So first we will select this tab and structural framing and hold Control key and select the column, structural column. Okay, and with that you see this eyeglasses, click it and say that hide category. Okay, so now this are left with the elements which we need to join, the architectural elements, not the structure part. So first we will join that, and this particular beam wall with the main wall, this beam wall with the main wall, and the column is already, yeah, fine. So this beam wall with this internal wall, beam wall with this column, yeah, fine, that's joined. This beam wall with these and herein, this with this, oh, that is already joined, so join, and this beam wall with this main wall, and fine, this with the internal wall, and yes, columns, this we will get rid of once we join them with the structural part. Okay, so this part is done. Now let's move to this part, and again we have here the beam wall which needs to be joined with the main wall, and yeah, beam wall with the main wall, and here to last one, no, fine, so that is all joined now, perfect. Yeah, this was remaining, this particular one wall, and yes, and join this with this, okay, perfect. And here is just one junction, but that is some little bit of glitch that we will just move, and no, how can we, and oh, a little bit of glitch. Once we join that, here we have we can now join that, join, and this with this, not allowing, maybe say join this with, okay, so it's joined, but forget it, and CC R enter, join this with, okay, that is a part of column, so architectural column, so that will be joined once we turn on the structure part. Okay, so with this, now you just press HR and you have all your structure elements visible, onto which first is that just press tab and the structural framing, with the structural framing selected, first hide that, so hide category, and first join all the columns. So join and structural column with the wall, yeah, and structural column with this wall, and structural column with this architectural column, so that will give you the perfect junction. Okay, so you need to do that for all junctions. So join and structure with this wall, structure with this wall, join and structural column with this wall, yeah, fine, and structural column with this, press tab, join and no, selecting the wrong element, join and structural element with this. It is very important that what you select, otherwise you will end up in errors. And then the structural element with this face, somehow not joining that. Yeah, it was joined finally. Join and the columns with the wall. Yes, and this to this, this to this, and likewise concrete rectangular columns and structural column with the wall, yeah, structural column with this and with this. Okay, and you see, at least for this 4 junctions we have perfect joint condition. Still the framing is yet to left, but that wouldn't be so much difficult. Only this, once we join these columns, the things will be easy. Join and yeah, join and yeah, and join and yeah. Okay, perfect. Again, click onto structural columns and this, structural columns and this, structural columns and this. Fine, and the last one, and yeah, that's done. Oh, this is remaining. Join and join. Oh, sorry. Join and this, and join this with this. Great. At least we have been able to join the columns. Okay, now this won't be a big issue because these columns are actually of the same size, so that will quickly join and we won't have to spend much time. And beautiful. And yes, and column with this. Structural column with this. No, we joined it wrong. We are supposed to select the structural column and then yeah, and also the structural column with the wall, and here in the same structural column and this, and then structural column and undo, join and tab structural column with this, structural column with this end. Yeah, no, this column is creating problem. Join and tab, and yeah, and you have to try a couple of options, and structural column with the wall, and structural column with the wall, and this beam wall with this internal walls, and also this beam wall with this, also this beam wall with this internal wall, and also this beam wall with that internal wall. And you see that here we have this beam wall projecting out due to the beam join, and here it is flushed, but here it is projecting out because of the structure. Fine. And with this this remains join and tab column with wall. Oh, we selected the wrong thing. Join and tab structural column with the wall. Yeah. And does anything remains here? Okay, this is the weird condition. I don't want to touch that. And now next is that we want to join the framing with the wall. So just press HR, and yeah, so join and structural framing with the wall, tab framing with the wall, again tab structural framing with the wall, and framing with the wall, framing with the wall, this column with this in order to get rid of that join and structural columns, and layer of plaster gone. Fine. And here too structural framing and the wall, structural framing and the wall, and structural framing and the wall, and do that for all the junctions in order to get the perfect joint conditions. So this is the way how can you incorporate the structure while working with an architectural model. So if there is any class direction, then you can judge that here itself in this environment. And here I guess there is some problem with the laying of that beam wall, and that I suppose, yeah, see, move and 0.5 of an inch in the X direction. So yeah, and the same thing here as well. First let's join, tab and structural framing with the wall, and same thing here. See, this wall is, the plaster layer should be 0.5 inch in this Y direction. Okay, and with that just join, and you just confirm this junction with the structural engineer. Right now I have just provided according to my understanding, but that might be the junction is weird. Undo, and yes, join and tab, okay, and once again join and the structural framing, or not that structural framing, join, and yeah, why am I not able to, yeah, this with this, okay, finally, and this with this wall, The purpose of doing so much of work is that we need to quantify it properly. Perfect. And here we still have a problem, but there is no problem, solution of which cannot be found. Yeah, after so much of hard work we were able to achieve this. And still here all the plaster layers are getting deducted, you see. And join and structural framing with the wall and structural framing with this wall. Okay, and structural framing with this wall, and absolutely perfect. Tab and structural framing with the wall, structural framing with the wall, wrong, structural framing with the wall, and structural framing with the wall, and structural framing with the wall. Forget about this junction. You know why this happens? Let me just click undo. This is because this layer of plaster has not been placed properly, so that is the reason. So move and 0.5 of an inch. Yeah, and the same thing here, I guess. So that's why it removed plaster from that beam. And with that done, we need to join it once again. Join and tab structural framing and the wall, and now perfect. With this, okay, and yeah, see how perfect junctions we have now. CCR intra. Okay, this is the structural element, not an issue. Now I'll be a little bit quick, hence the message has been conveyed and the concept is clear. So I'll just do the needful wherever necessary. Some junctions are really troublesome. See, again, this needs to be moved 0.5 inches, but we'll do that once we are completely done. join and join this with this, and here too both these beams. So where did the beam disappear here? Yeah, it's still there. Okay, and okay, done. And here too the plaster layer needs to be, so at 3 junctions. Before that, let me just join this, and okay, done, entirely perfect. Okay, and now if we just take you to the top view, and you see that here, see this needs to be flushed, and move, and likewise both this 1 and 2, both of this needs to be moved 0.5 an inch. Yeah, and with that, now if you join, okay, and here too, okay, and okay, here too, and again this, join, and join. Yeah, perfect. Okay, and this done. Is there anything left? Yeah, this, and this again, this needs to be moved, and okay, move it 0.5 an inch. Yes, and at that, join and this. Okay, the only thing is that now you need to take this portion a little bit forward in order to join forward. Yeah, and here too, just take this a little bit, because the concrete will join with concrete, no issues, but the layer of plaster should wrap. And here I guess move and 0.5 of an inch. Okay, and this needs to be connected, and likewise this needs to be connected here. Okay, and now let's join and select column, a beam, and this wall, and the column, and yeah, the circular column, and this, and the circular column again, and this. Okay, so after so much of work, we have been successfully able to have a perfect joint condition. Okay, what only thing remains is that just you have added the walls, so at every junction, but that wouldn't be an issue. So see, this was the purpose of adding that layer of plaster, that you cannot see the structural part, and this is the perfect joint condition. See, this is the perfect joint condition, how a beam connects to floor and that to wall, and we have that finished layer of flooring. Okay, so now you understand the reason of doing it so much detail. Okay, quickly, without wasting the time, join that at several junctions and join and switch order. Yeah, and join again, join and switch order, and join this with this, this with this, and this with this. Okay, this is for one junction I have shown you. The rest of you can just do it on your own. Fine, and this would actually be this particular floor, and edit boundary, and just go to first floor and just split this line and TR, and join this to this and get rid of this, delete. Okay, and edit boundary, finish, and don't attach. Yeah, and with that, just architecture and floor architecture, and just go for that first floor flower bed, and then define that particular portion here. Okay, we'll adjust it in section once. Let us place that. For here there will be a window, glass window, and you'll have a see-through. Edit and modify and join. Yeah, this is joined, perfect. No issues. Only thing is that we need to flush this level, align, and yeah. So in that case, edit boundary, first floor, and yes, this should go to the inside line on all the segments. And finish, and don't attach. 3D. And we have a flower bed there. Okay, but the only problem is section 1, and we need to provide it up to this particular level. So edit type and duplicate. Oh, sorry, not duplicate. Yeah, you need to duplicate this because this will affect the flower bed. So first floor, flower bed, washroom or toilet. Just be specific, edit type, and just reduce this, increase this brick beds to 275 mm. Okay, apply and okay. Actually, you can even have a slab at intermediate level, but that is again a structural concern and I'm not sure about it, so I am just following this method. Otherwise, in order to create this particular, you can have a slab or a PCC layer onto here, because anyway there is not going to be any flooring onto that. That will be just grass over there. Okay, and that has not affected this, thank God. Okay, finally, now what you see, that this particular floor at various junctions, just like we see this line because we joined it, but here it is not joined side by side, we cannot see that designated line. Okay, fine, And now with this, just select this flooring and this flooring. And actually, if I individually select, let's just use the power of Revit. So what we'll do is that we will select this and say that isolate category. Okay, wow. And just select all this by cross window and copy to clipboard and paste align to selected levels and paste it on second floor. Fine. So all the floor plates has been taken on that particular designated level. Okay, HR. Only thing is that this particular flower bed will not come on to this. This will come, but this won't. So just edit boundary, and what you need to do is that HL and delete this and delete this entire footprint. Okay, and with this flower beds only, just finish and don't attach. That's okay. R enter. Okay, and also this particular thing will now be roof. So just select and copy, so you can use it later, and just delete it for now and finish and don't attach. And yes, this particular floor plate, edit boundary, HL, and just delete this, and that will be just the pathway to the puja room, which will on this particular designated floor will be shifted to this location. And just finish and don't attach. Yeah, R enter. Okay, so now the next step is to bring all the columns on that particular floor. So what you need to do is that select any of the structural column. We can select this. And why did this particular column stop? This won't go up, but this would. See, let me just show you the AutoCAD plan, and that is my mistake, I guess. Yeah, see, so this particular column is going up. The reason being, what will this particular beam rest on? This beam, here also there is the one beam, here also there is the beam. What will that rest on? So this particular column needs to be taken above, so second floor. Yeah, and just take this particular and continue it till this point. Okay, no issues. And just join and join the, but we need to continue it a bit, 0.5 inch more in order to wrap. Yeah, right now just roughly I took join and join that particular structural column with this. Yeah, okay, perfect. So see, working with Revit is so easy. And also this is the parapet wall, so this particular will go a little bit up till this finish, and that finish is, I guess, that 75 mm. Oh, what happened? Undo. And this beam wall, yeah, nothing else. Okay, and top offset 75 mm. Okay, doesn't matter. Fine. So, and now just join that with this. Done. So working with Revit is very easy if you are properly used to it. Join and again. Okay, forget it. CCR enter. There might be a small glitch that we will just cover it later. But now what we need to do is that just select this particular structural column and say that isolate category. Okay, and what all columns will go up? So that is this all columns will go up terrace level. Okay, and this two won't go. HR, yeah, this two won't go, but all these columns will go. And now pick any of the structural framing, and that more difficult structural framing concrete beam, and isolate category. Okay, and just select all of this. Again, copy to clipboard, paste, align to selected levels, and onto second floor. Yeah, okay. HR, didn't copy. Oh, we copied it at the same place. So undo and redo. And now just select that particular structural framing, press tab until you find, I'm not able to select the structural framing, yeah, and say that eyeglasses and isolate category. Okay, and this is the second floor. We need to take it to terrace level, so copy and align to selected levels and to terrace level, not second floor. This is already on the second floor. Yeah, okay, and HR. Now we have to elevate the walls up till this particular level, so that we will do while going through this first floor plan. Okay, I'll select this one wall and tab and select all these walls and hold control key. Press one wall, select tab, control key, and again press tab. No, and we have to individually select and at least take this particular walls to terrace level. Done. Now select this, press tab, so that will select this three walls. Top constraint varies, so just change them to terrace level. Then press tab and select all of this, tab and select all of this, and hold control key, yeah, and tab and select all this, tab and select all this, tab and select all this, tab and select all this. Okay, all the walls are selected, beautiful, and change them top constraint to terrace level. And with this, all our walls has been taken to that particular floor level. Okay, and only thing is that this walls needs to be, but that we can do later. First is that now before bringing the beam walls onto this particular levels, let's first again we need to join this columns with this, so we have to do that. So structural framing and wall, structural framing and wall, and if you are conceptually clear, then that wouldn't take much time this time, because they are already taken from the level above. Okay, you see, so fast. Great. Done, and yeah, fine, real quick. That was fast and great. Oh, this is left. Undo and yes, and okay. Okay, this particular wall needs to be taken to the floor above terrace level. Okay, and join this to this, and the column to this. Perfect. Okay, and only this particular. Now we need to take all the beam walls, okay, to hide the structure. So for that, again, let's select this particular floor. This we cannot select. HH, and let's just select this. Hide, and select this HH and HH, and likewise all these floors we need to hide in order to bring the column and the framing to this particular level. Yeah, okay, so we have hidden all the things. Now just very carefully see this one, press tab. Now this tab, that is selecting all the walls, so we need to select individually. Okay, 1 and 2, 3, 4 here, and also 1, and 2, and 3, and 4, and all this architectural columns rectangular from first floor top level, just change this to terrace level. Great. Okay, now only thing left is for this particular portion, do we have any other column which is extruding out? No, we don't. And yes, this particular brown column finished layer, that needs to be taken till the terrace level. Okay, and here too we have, yeah, see, these two columns we have extruding out. So just select this and this and take them to terrace level. Okay, so with that, now what we need to do is select all the beam walls. Okay, so select this one and this it is not selecting, or actually just 1 and 2. Now this is going to be, press tab, beam wall 1, 2, and 3, and 4, and you see we selected the architectural framing, structural framing, sorry. We were supposed to select this beam wall, yeah, and here too there's 1, hold control key and watch this point. It should read beam wall, yeah, and here too that same beam wall, and here too beam wall. Okay, let's at least copy this much and just copy to clipboard and paste, align to selected levels and terrace level. Okay, terrace level 8 foot, This was supposed to be, oh, acha, okay, fine. So second floor and top constraint to terrace level, the top offset of 0. Okay, fine. And then select this one, and what are the constraints? So first floor to 4, yeah. So in case of this beam wall, we need to select a level lower. Press tab, beam wall, and also this particular beam wall. This one and this one. Fine, and this one. Do here, yeah, here at this point, but we are not able to visualize that. First, let's at least copy this much. Copy and align to selected levels and to first floor. And base constraint first floor. Okay, second floor. No. First floor. Yeah, I exactly made the copy of the same portion, but doesn't matter. Just change this to second floor and this to terrace level, and that will take it up. Okay, we don't have double counting of schedule. Okay, and this two, 1 and 2, 1 and 2, and just copy to clipboard and paste, align to selected levels, and this time let's select second floor. Okay, but this is again flushed wrongly, so we need to go to the top and move them, both of them, 0.5 inches. Okay, yeah, doesn't matter. So we need to join it here also. Join and join, yeah. Okay, and is anything left? Okay, this particular portion, this is really tiresome and annoying because it's hidden. So 1 and 2, and you can't even see 3 and 4. Okay, and copy and align to selected levels and second floor. Great. Fine. So is anything left? Nothing left. Oh, this one, this particular one. But if I just take you to the floor plan of this particular second floor, then this particular thing will hide. Let me just show you this plan properly. None, and yeah, so this passage onto second floor will stop at this point, and this will act as a canopy and roof for the floor below. Okay, so what we need to do is that we need to select this beam, oh sorry, not beam, and TR, and join this with this first. Okay, and then select this one, hold control key and copy and paste, align to selected levels and to second floor. Great. Okay, only thing is that we need to add this, and that we can do manually. Just select this CS, select similar, create similar, and with the constraint first floor top, yeah, perfect. And just pick this. Sorry, so too fast that was. So select this beam wall, CS, and pick lines and make this second floor. Okay, and now just create that. Oh, first floor base offset fine, and up to second floor. So what is the issue? I guess second floor and up to terrace level, yeah. And then create one here. Okay, press tab and continue that particular thing from this point till this point. That will wrap. Okay, so this is left again. So let's select this and this. Both of them are the beam walls. Yeah, 1 and 2. Sorry, this again is a problem. See, this needs to be moved and move it 0.5 of an inch here itself in 3D and join. Yeah, okay, and this 2 again. Oh my god. Join and okay, perfect. And 1 and 2 beam wall, 1 beam wall, tab, yeah, beam wall and this beam wall, and copy and paste align to selected levels onto second floor. Okay, and just join them. Join and structural framing and wall, highlighted elements overlap. Cancel and join, tab and yes, and tab and yes. Okay, so likewise now we need to join all this particular beam wall that we just took up with the structural framing. So join and tab and join, tab and join, and select the structural framing and then the wall, structural framing and then the beam wall. See, again here it is creating a problem. So this needs to be moved and move it 0.5 inch. Okay, and then join structural framing with the ball. Yeah, fine. But here there is this junction, so TR and join this with this. Okay, and join the structural column part, structural column with that. Okay, so absolutely perfect, fine. And join beam wall with this, beam wall with this, and for all the, but now it wouldn't be so much difficult, since till now you guys might also be well aware of how to join the geometries. And this is problematic, but no issues, we will do that. Yes, and yes. Join and framing with wall. Yeah, framing with wall, framing with wall, and doesn't matter, just where is the column here, HR. Oh no, there is no column actually, but press undo, and this was supposed to be joined properly. Structural framing with the wall, yeah, okay, but somehow it is showing. We will rectify that later. Right now let's complete this first. This particular junction, I guess if I just move this here, no, forget it. We need to waste time on, because some junctions are always meant to create problem. And yeah, also we need one beam wall over here, and press beam wall and CS and pick lines, and here, okay, and press space. But that again to move, and move 0.5 of an inch in this direction. Okay, with that, join and join structure with this, and structural framing with join and structural framing with the wall. Fine, and structural framing with this, and structural framing with this. Perfect joint condition. Few cases we cannot do anything, are meant to troublesome, so ignore those junctions. Join and yes, and join and this, okay, and join and also get rid of this, and this should continue to here till this point. Okay, let's move it. Okay, and from this point, this junction is creating a problem, so let's ignore it. Have we not? Oh, sorry, see, change the entire orientation, alignment, sorry, not orientation. And okay, forget about this junction, it's creating a problem. Okay, is anything rest left to join? And no. So with this, what you can do is that HR, fine, and this particular float plate, let me see what is the, okay, and this is the footprints of the terrace plan. So 3D, and yeah, this was supposed to be join and switch order. Okay, done. So sometimes things work, sometimes doesn't, but conceptually you should be clear. And before creating casting the slab for the terrace level, what I just want to do is that we need to edit this floor plate and add a floor plate and add the puja room here at this particular level. Okay, so let's just do that, and for that I need to select this wall and HH until I can select this floor and edit boundary, and then go to second floor and just create one simple rectangle and snap to the AutoCAD lines, and here too. Okay, and just pick and TR and join this with this, and this is not somehow joining. Let's take this to delete and okay, and just finish. Okay, don't attach. Fine, and now create the wall for that. So WA and puja room wall, yeah, same wall, and with base constraint second floor and top constraint terrace level. Just create that wall, and core face exterior, let me add the line of plaster 1 and 2, and this also needs to be continued. 3 highlighted wall overlap. Okay, and CS and join this to here, and then just CS and pick lines and pick this, so that will create it. Okay, perfectly. And this needs to be have a cut. Okay, and we can manually adjust that cut. Fine, and also we need to define the floor plate, sorry, not floor plate, but the top plate for this portion. So let's go to architecture and roof, and roof, and roof by footprints and rectangle. Just create one, select all of them, get rid of define slope, pick lines, and that too, get rid of define slope, TR, join this with this and this with this. Okay, and let's actually select the inner surface. And here too. Okay, fine, and base level is second floor. Okay, and edit type and duplicate, call custom or say puja room roof, and just give it standard thickness of 6 inch, and right now forget about the material, apply and okay, and just finish it. 3D. Okay, and just give it a, or actually select this chain of walls and give it a top constraint varies. How is that possible? Select this one wall and SA. Select all this. Yeah, fine. SA. Select all of these walls and just give it a top constraint of 3 inch, or let's say 9 inch. Okay, perfect. And this wall needs to be, let's go to first floor and delete this and TR and join this with this, and then create a wall cut from here till here. Okay, and just snap it to this point, which we can manually adjust later. See, this cut can be adjusted, but I think that is proper now, so we don't need to adjust it. Okay, and just select this particular roof and copy copy from, oh yeah, we cannot copy, we have to create it here. And just join the geometries for this, modify and join, and join the beam with the main wall, and join this with this. Okay, and just join, switch order, select this and select this, switch order and select this and select this. Okay, this and this. Oh, still it's not joined yet. Okay, perfect, fine. So with this, now we can add we can cast the slab for the terrace, but just tab, control and select this one, again tab, select control and select all of them, and just take it to slab top, final. To slab top. Yes. Okay, and let's create the floor plate for the terrace level. And what we will do is that we will just select this particular one, and no, we cannot do that, and for that we need to create that on that particular designated floor. So let's close all this unnecessarily. And where is the AutoCAD plan? Yeah, here it is. Just take that on the terrace level. So go to the terrace level floor plan and VG and imported categories, turn everything to halftone, apply and OK. And we cannot visualize anything. Yeah, only this wall. So again LI, find the common base point, not base point, what do we say, reference line. Okay, and yes, okay, fine. So now let's create the floor plate for this, and architecture and floor architecture, and no, this wouldn't be the floor, this is the top slab, so this wouldn't be the floor, and this would be roof. So roof by footprints, and edit type, duplicate, and call this terrace slab, and it's going to have the same formation and same composition. Copy, paste and paste, but the category will be roof. So this would be how much, let's right now say 100 mm, 20 mm, 12 mm, and finishing 90 mm. And let's add the finishing for this, and edit, duplicate material and call it one roof tiles, and copy and go to the material appearance library and select this particular one, or let's select this terracotta, replace, and oh, that's too dark. Let's just see appearance, and let's find information, appearance, and duplicate that and call it duplicate and roof tiles, and just give it a tiling of, let's say, 4 feet by 4 feet. Done. Apply. OK. And all these layers are the conventional, and that would be mortar. This would be sand bedding, PCC. Where is it? And this would be the brick beds for waterproofing, since it is terrace. So where is brick beds? Yeah, 100 mm of brick beds has been given, and this is not actually important because anyways that layer is not going to be seen. Apply. OK. And just pick lines. 1, 2, 3. This is the cutout. TR and delete and join this with this, but we need to get rid of this particular thing because that will have the walls above. The lift shaft needs to be excluded, and also the terrace. So TR and join this to this and put lines. Delete TR and join this to this, and one, 2, 3 and 4, 5 and 6, 7. And this way. L and yes. Finish this with this. Join this with this. And this to this. And select all of this. And check the define slope option. And just finish. Okay. 3D. Okay. Fine, but we need to check that in section, that how has it been laid. Sorry. And you see that this particular, this was supposed to be concrete. Custom face gray. Okay, fine. Okay, go ahead and okay. And this modify and align. This point should align with, or this should be given a negative base offset of -6 inch. Okay, and then should align properly. And still the plaster layer can go up. So join this with this. Switch order. Join and this with this. Okay, and also this bottom needs to be, because it will be visible. So insert down, and this would be finish 1/4 and layer of plaster and fine. Okay, and just give it 0.5 inch Okay, and again this needs to be minus 6.5. Okay, perfect. Join. Okay, at least at one junction we have it made it perfect. 3D. Okay, and this particular slab, copy to sorry, not cut, but copy to clipboard and paste align to selected levels and onto terrace floor. And what we will do is that go to terrace floor, and from here in edit footprints, and we will add that here. 1, 2, 3, 4 and 5, and get rid of this and uncheck define slope and finish. Okay, HR, we could actually make this particular portion a little bit lower and flush at beam bottom in order to extend this roof. So we can extend this roof, and then since it is categorized as roof, we can add skylight also. Okay, fine. So let's just select all this walls and just say that this unconnected height should be what, 9 feet. Yeah, 9 feet. And this roof to be, since it is having a thickness of 6 inches and it's good base offset, let me just guessing games. Okay, and yeah, fine, perfect. And now what we can do is that we can just edit footprints and go to terrace level and just make this a part of that particular thick lines, and from here edit, trim, extend and trim. Yeah, fine. Showing trim and trim. Show you 1 and 2. It's not perfectly snapping, so just delete and draw one line which is straight, and just get rid of slope, define slope. Okay, and we'll adjust it once it's drawn. Finish, and let's check in 3D. Okay, perfect. We can take the parapet up from here. Absolutely perfect. And with this, what we can do is just go to architecture and window, and we already have that skylight loaded. So what we can do is that pyramid skylight, and just press and window, and just add one, and then after adding you can even flip, and if not flip, then you can just adjust it and just have a bigger version. Don't forget to duplicate. I am right now just 5 feet by 5 feet. Yeah, fine. Apply and okay, and a bigger skylight. Yeah, great, absolutely perfect. Fine. So next is that we need to add the wall to this portion and the roof on this. So let's go to terrace floor and just add a simple WA and small wall, internal wall. Don't need to be add a 9-inch wall to that. We can just have a close shape. 0 and up to slab top. Yeah, fine. So 1 and 2, press space and just TR and join it, and likewise CS and draw one here as well to this point. And yes, okay, this is 6 inch, but this is 5.5 inch, so a little bit of that's okay, because this is the concrete wall and this is the masonry wall. Now what we can do is that we could why is this showing a little bit of Undo. Sorry. Let's delete this and CS, create similar and join from this point. Not finish face exterior, core face interior or exterior, because that wall would be having the layer of plaster. But we can keep it flushed. Yeah, it's not creating a problem. Okay, fine, flushed. Okay, and now let's go to slab top, but we cannot see anything. That's okay. We will just turn this underlay to terrace floor, terrace level, and yeah, we can see. So what we need to do is that architecture, and actually we can just take that particular roof and then edit its footprints. So see, copy to clipboard and paste to align selected levels and take it to slab top. With that, now I guess that we can see it. So just edit footprints and get rid of this and create new footprint. One internal, 1, 2 and 3 and 4. Actually this line, pick this line, TR, and join this to this. Okay, and just select all of this and defines the slope uncheck and finish. TR and join this and defines the uncheck and finish. And let me see. Yeah, but negative 6 inches only, that would be enough. Or actually, let's say that 0, and let's select this wall, this chain of walls, 1, 2, and give it a top offset of 12 inch or 15 inch. No, top offset of 15 inch, 15 foot I added by mistake. And then select all these walls. Why is it selecting all the wall? 1, 2, 3, 4, 5 and 6, and give it a top offset of 15 inch. Okay, perfect. And is this categorized as puja room roof? Yeah, fine. So we can categorize it by giving it a different name later. That's okay. And this one wall is left. Okay. Fine. So now let's add the parapet to this particular entire roof. Parapet, yeah, fine. So let's go to terrace level and WA and main wall, where is it? Main wall 9 inch and unconnected height of 300 mm, that is 90 centimeters, 900 mm, that is 90 centimeters, 0.9 meters, that is 3 foot. And just pick lines 1, 2, 3, 4, 5, 6, 7, 8. It's adding on the external edge, but that's okay. Once added, we can select all of them at one time and press tab and just click space, so that will reverse the direction. And this we could stop here, and let's go to 3D, and wow, okay. So working with Revit is easy. Okay, Now this particular one wall, which is the box wall, let's have a different material for its elevation treatment. Okay, and just go to edit type, edit, and this particular south wall is having the layer of plaster, ½ inch. So let's give that material, and I can use any existing material of say load bearing wall or anything, but I want to use a different material. So duplicate and one south wall, and go to image, and first, since we are going to load the image and not the existing material of Revit, we need to duplicate it first, south wall, and then select any of, let's select this particular one. That could be just tiling, cladding, sorry, the tiles which should be cladded onto that structure. And did we check its tiling? 4 feet, yeah, fine. Okay, apply, and okay. Wow, good. If you want, you could just, you see that this particular 9-inch, the core structure is, the parapet is exactly on the top of this, and this is the box that is created. So edit, and you just increase its styling a bit more drastic, something like 8 feet. That will be the stone tiles and not the actual stone wall, just the material of that. Yeah, fine, for better visual appearance. Now what next is that we need to add railings to this, but before that I want to just, so see some loopholes I want to rectify before delivering the final. So this entire thing will, let me just select this and copy to clipboard and paste, align to selected levels. First take it at first floor. Great. So here also there will be the window and flower bed, but the height won't be so much. We will have a lower height. This is 3 foot. We'll just take it 15 inch at this level, at intermediate levels, and this also needs to go down something like 12 inches. Let's trial and error. Yeah, fine. Okay, and that both again copy to clipboard and paste, align to selected levels, and go to second floor. Great. And let's take this particular, no, but this is a part of wall, so we need to individually make it on all the floors. So doesn't matter, first to go to first floor, and yeah, we don't need to make, we just need to extend the wall and just extend it till this point, LI, and have a reference line, and then just draw it. Okay, so that will flush, don't worry. And if you want to change the order, then modify and switch order. We'll do that in 3D, and this needs to be flushed at this. Okay, this actually is a joint condition of walls. So if I just click this, and with that, if I just say that next, yeah, but that will, and for this also next, yeah, perfect. And if I just go to 3D and see, then yeah, so that is perfect. Only thing is that, why is this appearing like this? This actually needs to flush first floor, and yeah, and just take this and TR. Okay, let's see. Okay, perfect. And first floor done. Okay, there is a small glitch. Yeah, actually this portion was supposed to be treated. I forgot, and we did add the beam wall on the top portion. We forgot to, yeah, so just doesn't matter, that's not a big issue. There's CS and pick lines and plain ground floor and 8 foot 5.5 offset and top constraint first floor, and just add 1 and 2 and over here 3, but that needs to be added 2 times space, so that will flush. Okay, and the joint condition we will just do it later. Right now it's important to complete the modeling part first. Joint condition we need to work out for every junction, so don't worry about that. Okay, now let's add the railing part to all this. This actually doesn't need to be so much big walls because we are going to add railing onto that. Select all this 1 2 3 and just give it 9-inch. Okay, and then just copy 1 2 3 and copy to clipboard and paste align to selected levels to first floor. Okay, sorry, undo. Before you copy you need to check the constraints, then only it will perfectly copy. And before 1 2 and 3 and yeah, it is already on the first floor. Yeah, sorry, copy and paste align to selected levels and take it to second floor. Better. And with that just CS and pick lines, add 1 here. Again wrong. So CS and go to second floor and just add 1 here and 1 here. Flip the direction. Okay, and then we could add railing to it, to all the, but also let's add for this, since we are here this, then CS pick lines 1 and 2, select this both, flip the direction, and also on the first floor herein we need to add the railing. So again that only CS and 1 and 2, not railing, the coping for to take that particular railing. And now let's see it in 3D for B, and yeah, okay, and this what's already existing, so just delete it. Now we could add railing to that particular part and also to these 2 pathways. Okay, so what we need to do is that go to first floor and just close this unnecessary views. It's not what we need is just the first floor and second floor, and let's go to first floor and herein just click railing and let's select that glass panel bottom fill 3 foot and base offset, let's give it 9-inch. Okay, and just draw on the internal and just finish. Flip it, not allowing. Did it place it properly? Yeah, but the only thing is that needs to be edit path, and again go to first floor and just take it a little bit in the center. Yeah, fine. Snap to the center. okay, and finish. And with that selected, CS, and also draw from here to here and here. Does it allows two path at a time, or is it going to show error? See, okay, and delete and CS from this to this and this. Yeah, okay, fine. Also add one to this pathway, so CS, and just select this point, move it 4.5, 4.5, and finish. CS, and click this. Here we can snap to the center of this wall and finish. 3D, perfect. And here too, that's great. And here, why is it hanging in air? 0. Okay, yeah, we don't have this particular coping or this wall pardi we don't have here, so offset wouldn't be. And first floor, and not first floor, second floor, but on the first floor we need to add that here, so CS and center to center and center, and this will have 9-inch offset. Fine, okay, finish. And now let's add that onto this second floor, and that would be the same. And CS and finish. Okay, and this last one, so again railing, because we are going to change the constraint, so 0. And actually let's pick this line, and once picked, move it 4.5, and same way here too, finish, and CS from this point to this point and finish. No, but actually this particular slab will be closed here and wouldn't have access. See, so it doesn't have an access because here there is a dead end, and this particular will act with the canopy and roof for this passage. So what we need to do is that this second floor and CS, and from this point to this point, finish, and TR, and join. You can actually make this edit path, and line and line from this point and TR and finish. I'm going to delete this because this will act as a roof. Okay, and this, let me just check. Okay, and here there will be a parapet wall for the wash area, that wouldn't be railing, so second floor and WA and 9-inch, and second floor and unconnected 3 foot. Just draw one tab, and from here to here, and from here to here, and TR and join. Okay, and select both of this, copy to clipboard, align to selected levels and to first floor. Okay, and go to 3D. Just check whether that parapet was added. Yeah, fine. The railing is also added everywhere. Perfect. So with this, the 3D modeling part of this entire project is complete. Now what we need to do is just add the openings, that is the door and windows, to the structure. But before that, I would just like to have a cross check of the joint conditions of the architectural elements to structural elements. We'll not do it for each and every junction, because you know that it's very time consuming process. So for certain major junctions, I will just rectify and let you know that what would be the joint conditions. So we'll start from this end, and yeah, see. So join this. So as soon as you join this parapet with this flooring, you see that this finished flooring get embedded within this wall, and this wall continues, and this much portion finishing layer of flooring gets, and the overlapping volumes get cut. Okay, so the same applies for this part as well. Join, and yes, now we need to go to bottom. So join structure with this and join this with this. Yeah, perfect. Likewise, join this with this and join the plaster to join, and yeah, done. And also this overlapping volumes of this walls, this is the masonry wall which would stop here, and yeah, perfect. Some junctions, yeah, good, fine, absolutely perfect. Let's move on to this, and again join this. So see, only the finished layer of flooring gets wrapped. And join and switch order. Yeah, sorry, that was wrong connection. Join and join this with this, and join this to this. Join and switch order. This is creating a problem. Join and switch order. No. Undo, and first join the structure with the structure, and with that just switch order. Okay, perfect. And join this to this. Yeah, perfect. This is a difficult junction, but we'll just show you that how to deal with it. Okay, no, join and switch order. This should, that is all right. Join and switch order this structure to this part, this. Okay, yeah, that is done. Okay, perfect. And this to join and switch order. There are a lot of guessing games, but keep trying until you get the desired join conditions. Perfect, absolutely perfect. Only this finished layer needs to be joined, and yeah, this to this. Okay, and the slab will continue, fine. This to this as well. Yeah, this is all right. Okay, and okay, absolutely perfect. See, only thing is that why is this plaster layer? So join and switch order. Oh yeah, see, so this is creating a problem again, so just ignore that. what is this line? Oh, this is the level line. Yeah, so let's just select that level line and hide it. So here, fine. So we can have a proper visual join and switch order. No, join, and this is join that. Okay, perfect. Join this with this to this, and join and switch order. Yes, switch order. Not working in few cases, but we cannot keep on doing that. I just made you understand the concept. You need to try it with several different permutations and combinations. And this join and join to this. Cut join elements. They are already joined. When did we? So just join this. Okay, and once unjoined, join it again. Okay, perfect. And join this particular structural, this framing to this wall. Yeah, fine. And join and switch order. Not that. Switch order and this to this. Yeah, fine, perfect. This is again creating a problem, but that's okay. Fine. So this was regarding the join condition of the structural elements, that is the beam, column and the floor, to the wall, that is the architectural elements. So we cannot, you see that it's taking a lot of time, so we cannot do that for all the junctions, but this was the fundamental and concept of it. With this you'll be perfectly able to schedule and quantify that. Okay, so now is the time to add the openings to this particular 3D structure. Fine. So where is the AutoCAD plan? AutoCAD plan is on the terrace level. Yeah, fine. So just take that all the way to first floor and open the first floor plan, and again we need to snap to this particular level in order to visualize the openings. So draw this line that would act, and then snap to this particular line. Okay, and with that the AutoCAD plan has been taken. So let's turn this to wireframe so that we can see the AutoCAD plan and we can see the placement of the openings. And here I guess that I forgot to add one wall, so let's just select this wall, main wall, CS, and change the constraint from first floor to second floor. Okay, and just add that. Okay, because if there is no wall then we won't be able to add opening. And here also there is a cut. This wall will stop here. Yes, and join. The same changes we need to do on the floor above, that is on the second floor. Yes, here this wall will join. That is actually a continuous wall, so here we might need to say CS and say that only from second floor to terrace level, and build one wall. Okay, and move and just join it. Okay, and here one wall we need, so CS and create that wall. Okay, fine. Now let's again go to first floor and let's start adding the doors and windows. So that remains the cut, the space for entering into the foyer, and then we have here the door. So what is the width of that door? Modify, and that would be 3 foot, I guess, 3 foot 6 inches. So DR, and that is a shortcut for door, and this door interior single panel 3 feet 6 inches. Yeah, that's already defined, that type is already defined, and I would just like to add that door over here. Fine, and at multiple places, what is the dimension over here? This is 2 feet 11 inches including the plaster. So CS and just edit type and duplicate this and call it 2 feet 6 inches. Oh, 3 foot, and just edit this to make it 3 foot. Apply and OK, and just add this 2 doors. Oh, but in order to place a door we also need a wall here, so this wall will split and split this wall, and yes, unjoin and take this wall up till this end and this wall up till this end, and add 2 4.5 inch, or this we can take this particular, wrap it and wrap it. The same changes we again need to do for the second floor, and here there is, oh yeah, that wall has been continued from, see, the base constraint is first floor and up till terrace floor, so that changes has been reflected here as well. So that's the best part, so we don't have to do it again and again. And just press DR and select the 3 foot, press space, and 3 foot is actually a little bit bigger size, and just make it 2 feet 10 inches for now. Apply and OK, and then try to add it, one over here and another flip here, and this is getting embedded in the wall. Okay, that's fine, that we can adjust just by changing the location of this wall, but right now I'm not considering that. And then DR, the regular flush door 30 inch cross 80, that we can add for the entrance to the washroom, one here and space, and one here. And also we have that at couple of places, common toilet, and we need to add it. Okay, and onto here as well, just roughly. And again, this wall has not been continued, so that's why it's not allowing to add the door. In order to place the door, you need to add a wall, CS and space. Okay, fine, and this particular door CS, and that would add here. Okay, so all the doors has been added on this particular floor. Now is that we need to add the windows and the curtain walls. Fine, so let's just do that. So WN is a shortcut for window, and this is a sliding window. Let me select 6 feet. This particular slice has been defined, so let's see that whether it adjusts here. Yeah, okay, and what is the width here? 1 2 2 and 7, so I guess that 8 feet will adjust here. Plinth office. Okay, and just align, yeah, fine. Just duplicate it and call it bedroom. Doesn't matter, it could be any bedroom, and just CS, create similar, and we have one over here. Where is it? Yeah, this is it, but that is again 6 feet, I guess. So 6 feet, and yeah, see, okay. And here there is a fixed window, so we need to change it to fixed window, 36 cross 72 and 36. Yeah, okay, let's just add. And I don't know why is it like that, but if you just see this particular opening, then the layer of wrapping is not seen even if you just flip the direction. But as far as the fixed window is concerned, if you flip the direction, then it won't show. But if you just change this to interior, then it will show the wrapping condition of the wall in the way that particular wall has been designed, wherein we have taken this at inserts, we have taken this both, and at ends exterior. So I don't know why it is like that, but I need to figure it out. Anyways, now let's just continue and select this and CS, and we will need a fixed window over here also, but that would be larger size. Edit and duplicate and call it 4 feet, or let's say 5 feet. Rename 5 feet. Okay, and just enter its width to 5 feet. Apply and okay. Okay, that would be a see-through. Wherein, if you remember, here we have this is the sunk, and sorry, not sunk, this is the cutout for the services to go, and this is that garden area. And in this particular fixed window, CS, and that will come here. But again, I need a smaller size, I guess. So which is this size? So edit and duplicate and call it 2 feet 6 inches, and let's make the width to 2 feet 6 inches. We need to adjust the dimensions in height, but that once we perceive that in elevation, so we'll be able to make out. This particular door is getting inserted. Why don't make it 2 feet 6 inches? But that is the dimension of a toilet door. But anyways, this condition is right now when we cannot take a pain of shifting this window. Instead, we can just make this size smaller. Apply and okay, and then align and flush with this, at least, yeah, and just convert that into the same 2 feet 6 inches and align. And yeah, okay, so this again needs to be CS and create here. Okay, this needs to be CS and place here, align, and oh, we snapped to the wrong line. CS and just place, first place it and then align it. Apply and up. Okay, and yes, what else? Yes, this two windows also needs to be reflected here, so CS and just place one here and place this CS and place this here for uniform elevation. And here we need to add two curtain wall, because if you see, then here wireframe and here too we have a window, but adding circular window in Revit is a tough job, and instead we can add just a curtain wall. And here also we have a fixed window, CS, and some smaller size. Let's select this 2 feet 6 inches. Does that come? Yeah, fine. One over here and one onto here. Okay, and yeah, we forgot this particular kitchen, so that CS, and we can add 2 windows, roughly one over here and one over here. Okay, now let's add a curtain wall to this curvature, and for that let me say WA, that is wall, and we have that custom curtain wall which we have added onto this particular portion. And here we have gymnasium, so but we need to replicate because we will make the changes and that would reflect here also. So just edit and duplicate it and call it bedroom curtain wall. And what we will do is, first let's try to place it with automatically embed checked, and the constraint to 3 foot, and the base offset of let's say 15 inch, and unconnected height of 8 feet, no, not 8 feet, 6 foot 9 inches. So that would make the lintel of 8 feet, and just add, pick lines, pick this. Okay, but what you see is that, see, because of the divisions, it is not accepting the curvature. So doesn't matter, what we just need to do is add the mullions to it. But before adding mullions, we need to add grid. So one over here, and you see, as soon as I add grid, it starts getting curved. An exact curvature, exact curved window is not possible, and that is practically also not possible. How can you make you have to go for customization and make a customized glass of that curvature. Okay, so CS, and just pick lines and place that here as well. But again, you need to architecture and curtain grid and add some divisions in order to make it appear a little bit curved. No issues. The last one, this particular thing, and for that I will again say WA and duplicate and call this living room. And okay, and I don't want to make any changes with this. Only thing is that it should have the base offset of finished floor level, that is 75 mm, and unconnected height of 8 foot, because 8 foot minus 75 mm. Oh, okay, let's not get into that. Okay, and just edit type automatically embed checked in. Just draw from this point to this point, automatically make that particular curtain wall, and just CS and do the same over here. Great. After doing all this work, we just need to see it in 3D, that how does it look. But before that, I need to add 2 windows over here. Sorry, I forgot. Just select this particular CS, and we could have the 8 foot. Yes, no issues. And this would be the 12 foot plinth office. So that is the same space, sorry. We can just duplicate, edit type and duplicate and call it bedroom. Okay, and fine. And does this needs to be flipped? Yes, and here too this needs to be flipped. And Okay, with all this, now we just need to visualize 3D. Okay, this particular, no, but yeah, actually, see, the reason of providing this inset here, it was just wanted to show you the joint condition, but actually this should go above. So HL, and this should not go above me, flip, that should flip, I mean. And with that, if you just see now, space, yeah. Okay, so just need to change the constraint, and the sill height should be 3 foot, and the height should be, in order to match the lintel, 5 foot, so that will make the lintel of 8 foot, and here too 3 foot, and the height of 5 foot. Yeah, so see, perfect. And just change this to 3 foot as well, and height is 5 foot defined already. Okay, this is perfect, I guess. If you want, you can add the vertical divisions also. Edit, and the vertical grid is 4 feet. Let's change it to 3 feet or 2 feet 6 inches. Apply. Yeah, that looks better. And likewise here too. The height, I guess, is wrong. No, fine, correct, no issues. The only thing is that we need to add a door onto here and have some more grids. So edit, and let's change this to 3 feet and this to 3 feet as well. Let's change this to 2 feet 6 inches. Apply and OK. And with that, if I just select this and HI, and we can just see this, then again we need to get rid of this mullions and place a door. So this is pinned, so unpin it and add remove segment, and unpin this and remove this, and insert and load family, and go to door, English Imperial, and doors, and yeah, single. So door, curtain wall, single, and select this panel, unpin it and load that door, curtain, single wall. Yeah, perfect. HR, yes, and no issues. Let's just check here, everything is fine. Here too, perfect. And here we don't have any opening, this wall, everything here in perfect. Only thing is that we need to edit this HI and just get rid of this, unpin and get rid of this mullion. And unpin, delete, and add remove segment and make it single glass, and unpin this and add that door, and HR, perfect, fine. So we need just to add a window onto this space. So let's go to first floor, and herein we need a window, and let's add some different window, WN, and that should be double hung. Yeah, let's add this window, or let's say casement window. Casement window, this instead this double hung will do. You can select any one, it's perfectly your choice. I'm just showing you the command. 6 feet and width to 6 feet. Or no, let's actually add 2 of the existing size. One over here and another one to here. And what is the height of that? Height, yeah, so make it 5 feet in order to match the lintel. You can see it in 3D now. Great. So with this, now again use the power of Revit. And how? Let us select all of this. Actually, only this level. This filter, check none and say that curtain panel, curtain wall grid, curtain mullions, doors and windows. Apply and OK. With that all selected, copy to clipboard and align to selected levels and place it on second floor. Great. Perfect. And only thing is that it didn't add this curtain wall. So why is that? Copy to clipboard and align to selected levels and second floor. Yeah, it did. And here too it should. Copy to clipboard, paste, align to selected levels and second floor. Okay. What next we need to do is that we need to add a canopy onto this particular portion. So let's go to terrace level, and this time what I'm going to do is that I'm going to select this roof and sloped glazing, and with that custom edit type duplicate custom sloped or custom glazing. And for the vertical grid, say fixed distance and grid 1, that should be let's trial and error. Which one is the horizontal and which one is vertical, I don't know. And with that, for the interior type, this mullions, let's select the bigger one, and for this regular, let's select a smaller size. And just copy and paste here as well, and select this larger size, copy and paste. Okay, so with that all customization, just apply OK and draw a rectangle on terrace level and just define slope, uncheck and finish. And see, as I said, this should be 4 feet and this should be 2 feet. Apply, and not even 2 feet, make it 19 inch. Apply, yeah, perfect. And now let's go to 3D. Great. Okay, I guess that border 1 and border 2, yeah, so wrong selection. This should be the larger one. Copy, paste, larger size, paste and larger size, and this interior should be the smaller size. Yes, apply and OK. Yeah, the support system of this, I'm not going into the detail of that. There will be the girders, the channel section coming, which will be taking this particular element, but right now let's concentrate on the design part. And let me just go to mullion and curtain wall mullions and rectangular mullion, and this size, type properties, change the material to appear like wood, copy existing material of Revit, and same here, type properties, and paste, apply, OK. Better, looks much better. Okay, so first floor and terrace floor, and we need to add that same, so select that. Yeah, tab until you find this dotted line saying that custom curtain wall in CS, and boundary this point to this point. We can also have sloped, gazing, but right now I'm just providing a simple wrong placement. Terrace level, yeah, fine. And why is it roof, not roof, dear, not roof. Sloped glazing, and onto that also the custom glazing. OK, and finish. Don't attach. 3D. OK, great. Fine. So this is the way we have completed the residential apartment. Last thing left is this particular one glitch, which we will rectify here itself in 3D. And how is that we are going to do is that edit profile, we cannot see anything, so CC, still we cannot see anything. HL, that is hidden, no, not HL, SH, that is shaded. I have added all these shortcuts so I can efficiently work, and just pick this line. OK, TR, and again join this, pick this profile 1 and 2, and join this to this. This should actually, no, delete, and pick lines, and here in there, yeah, OK, got the line. And what we need to do is that roughly just select this line and TR, and join this to this, and join this to this. OK, and with this, if I just finish, then that should follow. Yeah, perfect. And we have a dead end here, and R enter. The only problem is that I didn't thought earlier about this particular, so this is a small glitch, pardon me for that. Now we cannot do anything, only option is to lay one custom step over here, and then to see here also there is an inverted beam, so how we need to raise this particular flooring by to the top of that inverted beam. So these are some small errors which I made. Also, what we need to do is that we need to take this particular curtain wall up to this particular location. So again, let's use the functionality and power of Revit, align to selected levels and to second floor. Yeah, okay. Even if you want to add some opening to this particular one wall and terrace level and let's take this section over here and pick this wall and say edit profile. And which section is this? I need to check section 6. So edit profile and go to section 6, and onto that add a couple of random cutouts, maybe of 1 feet. This should be okay. It's 1 feet. Copy and just place it and have a couple of more, 1 and 2. And then adjust it a bit according to the. Okay, let's just see it in 3D. Yeah, see, HL, and that's perfect. So just finish it and go to terrace level and wall and add simple curtain wall onto this cutouts and CO, or let's just first confirm whether it's been placed properly or not. HL CC. Okay, see, adjust according to the size of the cutout, and with that selected, CO and place it with multiple checked on, place it. Okay, so now when you see it in 3D and R enter, you have your glass slits. Okay, what left for this particular structure is that for this particular residential apartment is that we need to add the typical staircase, which will be going from basement level up till this terrace level. And for that purpose, let me just take you to this particular plinth ground floor level, and wherein we have our AutoCAD plan, and let me just take you to this section. Then what you see in this section, that from basement to this particular plinth ground level, we have the floor height of 13 feet. That is because we have added a 3 feet of plinth. Okay, so in order to lay the staircase, if I just measure this from the finished level of this to here, then we have 12 feet 9 inches, and then the typical 10 feet of floor height. Okay, so what we need to do is that we need to raise this particular plinth by 2 feet 9 inches in order to have the uniform staircase. So what I will do is that I'll just go to basement slab, and right now, just to show you the function and command, I will just lay a floor randomly, but the point is that this will be a floor of 3 feet, that is 2 feet 9 inches. We will be having 6 steps, that is 6 risers on to this basement level. Okay, so right now I'm just giving it 0 to 3 feet, fine, and with that we would be able to have a uniform height. Okay, so see, okay, so with that what we can do is go to print ground floor and then architecture and stair, and we'll select this monolithic steps going from plinth ground floor up till first floor. So the desired stair height is 10 foot and the desired number of risers with 18. We have this 617256, some variable, that is something 6, between 6 and 6.5. So that is fine for residential staircase. So let's create the sketch, and first is that we will sketch the boundary line. Okay, and just take this boundary line and create another boundary line, 1, 2 and 3. Fine, now we need to create the risers. So you see, as soon as I click this create risers, it says that so much created, so much remaining, and this should be snapped to this point, and 1, 2, oh sorry, not boundary lines but risers, and then pick. So Yeah, see, and again it has this, so risers and pick lines, and 2, 3. So see this, watch here, and now it says that 18 risers created and 0 remaining. Fine. What next is that we need to add the stair path. So from here to here, and from here to here, and here, the stair path should connect all the risers, and with this just finish. And let's add the material, and yeah, fine, the ramp material has been already added to the staircase. That's fine, and with that I'll just say finish. Okay, so the rail is not continuous, that's fine, because of its custom shape it won't create homogeneous slab. And also this railing I need to delete. And now if you just see this in section 1, then we cannot see it. That is because the view range of the section is, and if you just take this here and see this, then you have your staircase going from this particular floor, this plinth ground floor, up till first floor. Only thing is that we need to elevate it by 75 mm base offset, and top offset also 75 mm, because it has the finished floor. And here the finished floor level is more, I guess. So wireframe, and no, that's proper. Eventually that adds up, yeah, 6.5, yeah, perfect, no issues. Okay, so now let's just visualize this particular thing in 3D. And how to visualize? So for that we need to go to section box and go to top and take this portion here and this over here. Let's just take this here, and yeah, so see, and let's just select this all walls and temporarily hide it until we can just see the staircase. So this is your staircase, which has been laid from this particular finished floor up to this particular finished floor. Okay, now what we just need to do is that add railing to it. So railing, and just select one simple guardrail pipe and say that place it on stair ramp. Sorry, yes, and railing and place on stair ramp. Okay, and just select not glass panel bottom fill, but just the guardrail pipe, and just select this, and that will lay the railing. Okay, see, perfect. You can change the material if you want, but right now I would rather focus on modeling part. So with this, what you can do is that select this staircase and this particular railing, and say that copy to clipboard and paste align to selected levels, and I would like to place it on basement slab, on plinth ground floor we already created, on first floor and on second floor, and just press OK. And we have our staircase created on all the consecutive levels. Okay, only thing is that we need to elevate this particular staircase, giving it an offset of that particular plinth created for our purpose. So section 1, and just take this particular staircase and give it an offset of say 2 feet 9 inches. Yeah, so that will perfectly lay it. Okay, so this is how you can create a typical staircase between your all floors. Okay, so now with this I will just get rid of the section box, and yeah, fine. We are seeing it on the wrong side. Not only this, you can use the existing library of Revit in order to add some components. That is like if you want to add trees, human figures, vehicles, so that where can we access it from? So there's component, and just place a component. So right now what you can say is this different types of trees as a preloaded element, preloaded library of Revit. Okay, and this parking space. But what you can do is that just go to load family, and herein this is the path, that is libraries and English Imperial. You have lots and lots of libraries which you can add to your project, that is this furniture and all the different types of furniture, that is the custom library, that is the libraries that is created by Revit which you can use. And English Imperial and this entrage and this car and this human figures and this different other types of vehicles. Okay, and if not that, under the specialty equipment, if you just use, you can use any of this domestic and this, you see this existing library of Revit. See, I will just show you a couple of them. Okay, so you see that using all that custom library, I have created this elements, that is, this is the entire kitchen unit which have this oven and refrigerator and oven and dishwasher and everything, this cooktop, and this are all the existing libraries of Revit. Okay, and this has been created with all the 3D drafting commands, and once created this custom furniture and this custom design, you can load this to project and make it the part of project environment. Okay, fine. So that was pertaining to the modeling of this particular residential apartment, which I had shown you from scratch by laying the footings and columns and the structural elements and connection of that to architectural elements, joint condition and everything. So that was pertaining to phase 1, and all of that, those particular 3D furniture library which I just showed you the path of, I would rather prefer adding it with Enscape, that is this particular render engine. Fine. So now with that, we are done with the phase 1 of Revit, and now we will start with the next phase from next class. Okay, bye. So practice and get up to this point and let me know if you have any doubts or queries.
So that basically pertains to the modeling of the 3D interface of Revit, wherein we have executed this entire project, which has this unique form and this typical G+3.5 residential apartment with the typical floor plan from scratch, wherein we have designed several different types of footing, foundation, and we have also laid the structural elements, that is the column, beam, floor, and its connection to architectural elements, that is wall, with its several wrapping layers and joint conditions. But as I've been always saying, that Revit is not only about the modeling of the 3D interface, but it's very prominently and efficiently does model the 2D interface, which again has the bifurcation. That is, the first part refers to the documentation of several different types of drawings with several different disciplines. So let's have a look over that. So this refers to the presentation set, wherein we have the entire site layout showing its location and the view from top with all its attributes and the details. The next is that the typical floor plan. The typical floor plan, which has again this presentation set showing the displaying the materials and every information that is needed for this particular presentation set. Fine. And again, with this floor plan, we can also create different sets. That is, this particular floor plan refers to the working plan, working drawing, which is feeded with all the information. I have not completely detailed out, but just to demonstrate you that how to create different drawings of different disciplines. And this particular one wall I have detailed out, wherein I have provided it with dimensions. And Revit also very prominently and efficiently gives different types of dimension. That is, this is the continuous style, this is the baseline, this is the ordinate style, since several different designers are often interested in giving dimensions in different way. Okay, so that can also be very efficiently done in Revit. Next is that if you just watch this particular presentation set, then this is the room tag. This is the room tag which is showing the name of that particular area and its square feet. Fine. But if you just watch this particular working plan, then this particular room tag is showing its length by breadth. Fine. So this is how you can manipulate between different working styles for different sets of drawings. Next is that within this particular presentation set, you can have several different options, wherein you see that this particular option is showing the furniture layout, the configuration of the furniture layout in this way. If I just switch to this option, then this particular option has the configuration of furniture layout in this ways. This not only refers to the furniture layout, but you can also create different options for the 3D views. Fine. So let me just show you that. So this is the 3D view, and if I just switch to this option, it will take a bit of time to regenerate since this file is loaded with lots of detail. Yeah, so this is the option which is showing the flat roof. Fine. So this is the flat roof option, and this is the slope roof option. So that is the contemporary style. This particular slope roof option reflects the traditional styles with all the traditional openings. Fine. And this traditional columns, traditional wooden columns, and this railing type and all that. Fine. Not only this, you can also have an exploded view of any particular area if you want to document it within your sheet composition. Just coming to that, also you can have this elevation sections, whatever you want, in whatever style you want to present. Fine. So also, yeah, you can have this legend components. You see that we have this legends and door legends I have created, but the only flaw of this is that you cannot have a section of this. You see that the section option is grayed out. Instead, you also have in Revit this typical drafting views, wherein you see that I have loaded this AutoCAD plan because we as the designers are working on AutoCAD for several years, over years, and we have lots of our details established already on AutoCAD. So drafting like AutoCAD on Revit would be difficult or would be time consuming. So it is very easy to insert an AutoCAD drawing with precise layers and also in scale, and load that particular AutoCAD drawing into this drafting view and just make it the part of sheet. So this is that sheet composition, and again this will take a bit of time. Yeah, of course, a designer will never issue a sheet in this format, but this is just to show you that drawings of different scales and different disciplines can be loaded onto this, and you see that this particular working drawing plan is reflecting 2 revisions which are part of this format. Fine. So this is how you efficiently make all the details. Now this was pertaining to the first part of the 2D interface. Now as I said that 2D interface also has the bifurcation. So what is the next? Next is that you can very efficiently design the different types of schedules just by feeding the information, by adding the fields and information that you want to document. That is, this is showing the area gross plan, schedule of area for this particular area gross plan. That is this private spaces, public spaces, circulation, semi-private, services, and etc. Okay. So just like that, we have this door schedule, and this refers to all the different types of doors that are used in this project, which is costing, that are just the approximate values, and you can add whatever field you want and whatever information you want to feed. Also you can, if you want to just see that what are the number of floors on a particular level, then just go to level and make it equals to, let's say, first floor. So that will show you that this all are, then there are 13 doors on that first floor, and this its details and description, and of which it also shows that type D2 has 2 instances and type D3 has 2 instances. Fine. So just like that, you can have the floor schedule of all the different types of floors created at different levels. you can have the wall schedule. So this is the wall schedule, which are showing that there are this many types of walls in the entire project, with its base constraint, top constraint, its length, area, width and volume. You cannot add the field of level for walls. And the same way, this is the window schedule. Fine. Also you can filter the windows for a particular level. So let me just say that I want to see the number of windows on first floor. So that will show you the windows, that total number of 20 windows, that is this particular, so many types of windows have so many instances. Fine. So this was about the scheduling part. Also you can have the material takeoff, that is the floor material. So you see that I have already filtered this particular thing, that for plinth ground floor you have several different types of material with so much area. And this is the wall material takeoff. Yeah, so this is showing you the several different types of walls for the material, several different types of materials which are used for the wall. For wherein if you just want to filter that what is the let me say that material name, and that should be equal to plaster. So where is it? Yeah, plaster, and just say okay. So that will show you that for your entire project, this is the area of the plaster and this is the volume. Fine. But how to cross check that whatever you have scheduled and whatever values, this particular door schedule, floor schedule, window, wall and all this values are correct or not? So the only way is that from day one you have to do the modeling in a very precise way and perfect way, and you should not have any error, and all the values should be very much perfectly, and the joint conditions should be very perfectly done. Just to demonstrate this, I have taken a smaller example, smaller scale, wherein I have designed this particular 3 meter by 3 meter of wall which has height of 3 meter. So then if I just take you to this particular, let me just click WT and let me get rid of this wall material takeoff for now, and let me just see this side by side. So if you see that this particular schedule is showing yeah, so you see, so width is 2.26 and length is 3.52 in case of this wall, wherein this particular wall is 3 feet. So that's why 10.56 meter square is the area and 9 meter square is the area, and this is the volume. So how have I derived this particular values? So that is referring to its joint condition. So this is perfectly joined, wherein this the wall thickness, since the wall thickness, if I just take you to this wall, the assembly of this wall, then this particular wall is 0.23 with 0.15 mm of plaster, that is 19 mm and 12 mm external and internal, but just to round up and have a round figure, I have added the 15 mm of plaster on both the ends, so that will give us a round figure. So 0.26 on this side and 0.26 on this side, so both of these walls are reading 3.52 length and its width is 0.26, so that's why the area is 10.56 meters square. Otherwise, if you just talk about these two walls, then there are 9 meters, 3 cross 3, that is 9 meters square. Fine. And I have just roughly added the cost factor, that in my neighborhood the construction of 1 square feet of masonry wall of 9 inch is 140 rupees square feet. That's just a random figure, and that would give you the cost of that particular wall, and that is just by adding that particular field, that is cost of masonry, and giving it a calculated formula, that is area times cost times 10.76, because this 140 is per square meter and this particular thing is in per square feet. Sorry, this 140 is per square feet and this particular wall is in metric system, so that's why you need to multiply it with 10.76, because 1 square meter is equal to 10.76 square feet. Fine. So that is why I have created this particular thing, and it also calculates the number of bricks, wherein I have added the calculated formula volume divided by 0.0003 meter cube. So how did I derive upon this particular figure? So to demonstrate that, I'll just show you a simple PPT wherein you see that I have considered that the size of one brick is with mortar or plaster. The size of one brick is 0.24 cross 0.125 cross 0.085 meter. That is, I have just added 10 mm to this conventional size of brick in my neighborhood. I have just added the 10 mm of mortar or plaster to that. So that will give you the volume of one brick, that is 0.00255 meter cube. So number of bricks in 1 meter cube is volume of one brick, that is this, that is 1 divided by volume of one brick, that is this figure. So that would give you 1 divided by 0.00255, that is 392 bricks. So I have just used that particular formula, and by that I have derived the number of bricks. That wouldn't be accurate, but at least that would be accurate enough. Then you calculate on AutoCAD with calculator. You set for hours and hours, fine. So that was pertaining to the schedule. Also, this you have this material takeoff, fine. So just as I showed you that this particular material is showing the main wall, and from this, if you just want to filter, and just go to filter and say that material name, and that equals plaster. Okay, so that ways I have just added this calculated field wherein I have entered the material the cost of plaster, which says that material area into material cost, and again 10.76, because the cost of that material which I have added 80 rupees, that is for 1 square feet, fine. So you need to convert it into square meters. So you have to be very precise while modeling from day one, and regarding this joint conditions of the walls and everything. Okay, so that was just a small demonstration regarding the various different functionalities of Revit. So guys, if you want to learn all this in detail, then kindly enroll for this course, Master Diploma in Revit BIM, and let's learn together and let's grow together. Fine. Have a nice day. Happy working with Revit, and bye.